Hi, my name is Ruth and I'm from New York City.
Hallo, ik ben Danny de Klerk uit Italië.
Bonjour, je suis Jean-Philippe Encausse de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hej, ik ben Sammy uit België.
Cześć, tu Bartosz Mikułski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan，来自台湾。
你把一个人物，阿本巴斯卡就是阿雷梅西。
Hello everyone and welcome to the Global AI Developer Days. My name is Sjoukje Zaal. I'm a Microsoft RD and an Azure and an AI MVP and I'm from the Netherlands.
And I am Sami. I'm also a Microsoft AI MVP and I'm from the country of chocolate and beer, Belgium. Now, the following 10 days are all about learning about AI with a high focus on AI developers. But before diving into this event, we want to look back at the Global AI Bootcamp held back in March this year. Well, the bootcamps were locally organized by different communities all over the world. Now, it was an evening or a day event packed with sessions and workshops. To highlight a couple of those bootcamps, we invited some community leaders and program managers from Microsoft to the behind-the-scenes sessions, where we talked about their communities and about the new products Microsoft had released. And with over 5,000 viewers live and on demand, we can say it was a huge success.
Yes, it was. But today we are kicking off this event with a series of inspiring keynotes from NVIDIA, Microsoft, and Accenture industry leads. We will cover responsible AI, product announcements, and machine learning operations. And we will also have a panel discussion with our keynote speakers where you can ask your questions as well. So if you have any questions, use the chat and we will ask them to our speakers.
But today we are kicking off the event with a series of inspiring keynotes, and I was not supposed to say that. So let's talk about tomorrow. Tomorrow we will have an 18... I'm so sorry. Tomorrow we will have an 18-hour live stream full with great sessions from the community. From who can we learn the best? Of course, it's from the people who are working day in, day out with all these kinds of products. Now, after that very long live stream, there will be 7 days where local communities are organizing their own events with talks and workshops.
So if you want to see the full schedule for today and for tomorrow, please take a look at our website, devdays.globalai.community. Let's have a look together. Here you can see our website on devdays.globalai.community. We have our player here that you can use. We have our chat on the right side where you can ask your questions, or maybe you want to let us know where you're from. That's also very nice to know. And we also offer interpretation into international sign. So you can click the button to show or hide it, whatever you prefer. So let's take a look at the schedule for today.
Yes, so we're kicking off, well, with welcoming you all here to the show. And then we're going straight to Ekaterina, who will talk about AI skills beyond developing. Ekaterina works for Accenture, and we're really looking forward to hear more about what she has been doing. From there onwards, we go to the principal data scientist at Microsoft, to Francesca Lazzeri, who will talk about MLOps for continuous learning. And after that, we'll go to some more people at Microsoft. We will have our infamous Eric Boyd, who's been with us like every year. And also with this event, he's here. But he's bringing a friend. He's bringing Beatrice Stolnitz, and they will talk about Azure AI innovations at Microsoft.
And then next will be Manu Veer from NVIDIA, who will talk about the developer essentials for the new era of AI. Also a very interesting session. And then we go into our panel discussions, where our keynote speakers will join us to talk about the future of AI. And then lastly, Ruth from Microsoft will join us as well, and she will talk about improving the fairness and reliability of AI solutions. So if you want to have some more information about our keynote speakers, take a look at our website, click on their profile picture, and you can read all about them. So let's take a look at what tomorrow will bring us.
Yeah, so we're starting at 6 a.m., which is 6 a.m. Central European time, but depending on where you are opening the website, it should be on your local time. So have a good look at it so you don't wake up at the wrong time. But we will be here in the early mornings. And we're going from 6 a.m. all the way to almost midnight, where we're packed with sessions by community leaders, by student ambassadors, by AI MVPs from little companies or AI tools that have been, of people who have built AI tools that are going to talk a bit about their toolings that they've built. We're talking about Form Recognizer, we're talking about a hackathon that they've organized. We've talked about some comparison between different cloud vendors. So it's really packed with interesting sessions that we're looking forward to learn more about.
Yes, these are the people that work with AI on a daily basis. I'm
Exactly.
really looking forward to each and every one of these sessions.
Yeah.
Really great. So if you want to know more about the schedule, please take a look at our website and do that at your own pace. Look at all the sessions that we are going to host. And if you have any questions today or tomorrow, please ask your questions in the chat. So Sammy, what are you looking forward to tonight?
Well, for tonight, there's two sessions I'm really looking forward to. The first one is by Manuvir from NVIDIA, because we all know NVIDIA as a hardware vendor. We all want their big graphic cards in our computer to play games or build AI models also, of course. But what does NVIDIA actually do concerning democratizing AI? To be honest, I have no idea. So I'm really looking forward to learn more about that. And then the last session with Ruth, where she's going to talk more about responsible AI. Responsible AI is something that's quite close to my heart, and it's something that just needs to be talked more about because it's so important. So I'm really looking forward to learn more about that.
Those are two very interesting sessions. Yeah. I'm also looking forward to the one of Eric Boyd with the
of course
Azure announcement.
It's always a treat to have him as one of the keynote speakers.
Yeah, definitely. Okay.
Well, we can have a quick look also to where people are joining us from today. We have, for example, hi Alex from Germany, welcome. We have Sheikh from India. We have from Colombia, Damer, thanks for joining you all. We have Fernando from Belgium, hi Fernando. We have Beatrice from Basque Country, Spain. So many people from different places all over the world. So we're very happy to have you all here today. So please throw in the chat where you're from so we can say hi to you. Again, if you have any questions, don't hesitate to throw it in the chat so we can use them in our panel discussion afterwards or even after the sessions by the different speakers themselves if we have time for it.
Okay, so it's almost top of the hour.
Yeah.
So we need to get ready for our first speaker. We will be back in a minute with our first speaker, Ekaterina.
Hi, my name is Ruth and I'm from New York City.
Hallo, ik ben Danny de Klerk uit Italië.
Bonjour, je suis Jean-Philippe Pancos de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hey iedereen, ik ben Sammy uit België.
Cześć, tu Bartosz Mipulski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan， 来自台湾。
Welcome back. So we're starting with our first keynote today, and for that we are welcoming Ekaterina. Let's hope she's in our call. Is she? Drum rolls, please.
Hello from my side. I
Hi,
hope you can hear me.
Ekaterina. We can hear you loud and clear, but sadly enough, we cannot see you yet. We have this beautiful Teams logo, though. There you are.
Hi.
Hello. Very nice to meet you.
Likewise. How are you doing?
Very good, thank you. Super excited for the event, especially after the introduction you gave. So looking forward.
Ekaterina, can you please introduce yourself? Who are you, where are you from, and what you do at Accenture, if I'm correct?
Yes, of course. Thank you very much. I'm Ekaterina and I'm from Bulgaria, Sofia, Bulgaria. I currently work for Accenture and I work for the company as a technology consulting manager. So I'm working in the field of data and AI in the Accenture Microsoft Business Group, especially dealing in the area and the field of the resources industry. I'm specializing. I'm an MVP for AI. I'm specializing in data, in artificial intelligence. When it comes also to open data, to data philanthropy, this is the topic where I'm actually aiming in completing my PhD in. So this is me in a nutshell.
Okay, thank you very much. Well, I think your session is going to be more what kind of skills that we need. So we're looking forward to your session. So the platform is yours.
Thank you very much. Let me just share my screen. Okay. Just tell me if you can see it.
Yeah, that's a go. Thank you.
Great. Thank you very much. So hello, everyone. Today, I'm going to talk about the skills beyond developing and beyond programming in the area of artificial intelligence. But I cannot start with AI itself without starting with data. As you know, we are currently living and we're currently working and talking and having this event in an era of data where we are surrounded by devices, we are surrounded by environment full of data, constantly enriching by data, by innovations, by the different devices that we're placing around ourselves and that we're buying and using. And when we're talking about data, we're often just transferring to the term big data. And then we freely use big data and AI, like this is the new big thing. This is the thing where everybody should be looking at. This is the thing where everybody should be developing their skills at. But when we think of actually what is data, like the pure data, the data points that we're observing, this could be the weather temperature outside, this could be the humidity, this could be our age, like all of these could be very different data points. And when we're describing a term like big data, when we step out of this terminology only for data, we're already talking a big amount of data. We're talking about the volume. We're talking about value. So is this data that we're considering, is this data that we are understanding as big data valuable for us? Or is it just a bunch of data points that we randomly collect around ourselves? Then we're talking about the pace of this data. We're talking about the different sources where this data is coming. And this is a huge topic. Like, is this data that we're collecting, is it trustworthy? Is the source that it's coming from actually reliable? Are we talking about the trustworthiness in this data with regards to what we're trying to solve? So when it goes to data, when it goes to big data, we're talking about different aspects of this data. So qualifying, quantifying, and really talking about the value behind the data, which is very important because the next step after the data is the intelligence. So what happens after we collect this data? What happens after we look around and identify the data points? What happens after we determine what's big data for us, for our company, for our university, for our community? Then what we need to do and what we strive to do, every one of us who is working with data, is to transform this data into intelligence and into information. And once we do that, once we connect those data points, once we manage to get to this state of having this information, we'll be able to tell that we or our organization is data-driven, that we're becoming adaptive, that we want to be using the latest technology, we're agile, we are innovative. Like this gives us the opportunity to come from simple data point to mapping those data points into information, and then getting to a state of wisdom, getting to a state where we can actually use this information, we can actually use this data to make more decisions, to be more adaptive, to be more agile. And overall, when we get to this point, we're saying, okay, but there's something more. Like, this is not only the era of data, this is not only the era of information, but this is the era of artificial intelligence. And this is where it gets loud. Everybody's talking about artificial intelligence. We're talking about the future of artificial intelligence, the past of the artificial intelligence, and the current state of the artificial intelligence. But have you ever thought how many of the people talking about artificial intelligence actually know what that is? Have you thought of all the articles where artificial intelligence is written down, or the news where we hear about artificial intelligence, or those debates where it's talking about the ethics of artificial intelligence and everything? We're often getting back to the root of what exactly is artificial intelligence. And if you think about the two words separately, what is artificial? Just ask this question to yourself. So if you look around, can you point at something that's artificial? Probably you can point at the laptop, or probably you can point at your phone or your curtains. This is artificial, right? This is very easy to spot. Now, try to describe the second part, intelligence. So can you define intelligence now? And I'm sure you can, but it won't be like pointing at something around you, like this is intelligence. So then when you combine those two, when you combine artificial intelligence, then you get to the root cause of what, and the root of artificial intelligence, which is the human intelligence, the human actions, the human thoughts, the human emotions that lay and that serve as a base for artificial intelligence. So this is the human intelligence and actions invested in enough machine memory, in enough speed to process. Like all of these artificial components that help our intelligence and that help our actions, our thoughts, our mathematics to happen fast, to further develop, or to use the latest technology available. This is artificial intelligence, and it keeps raising questions, a lot of questions in our world. So what do we do with that? Like, what do we do with this AI? What do we do with these robots? What do we do with these advanced algorithms, with this machine learning, with this computer vision, with these enhancements that we're seeing everywhere? Are we just talking about it? Is it really happening? Is AI going to take my job? Are we talking about the ethics behind AI? Who understands AI? Or can I study AI? Can I teach AI? Can I join a lecture and understand what's AI and then start working it somewhere or somehow? Is AI within my house? Is AI going to be in my life within 5 years? So these are a lot of questions, valid questions that everybody asks themselves in a different manner, right? You can ask it within your business. You can ask it within your family, within your house. And to know how to answer those questions, some people start reading articles, some just disregard it and accept that AI is only robots. Others try to educate themselves, find the learning program. And there are people who want to, from their younger years, they want to start building skills into the area and really get deeper into AI. Thus leading us to today's session, skills in AI, and skills in AI beyond developing. So if I say that there is a specific set of skills in AI, I would say that I'm right. So I think that the skills in artificial intelligence are programming, mathematics, machine learning, statistics, and natural language processing, deep learning, computer vision. I could really bravely say that these are the skills that are necessary for a person to be AI worker, or to be oriented towards AI, or to be successful in the AI area. And then I would go to examples. I would go to humanoid robots, right? This is AI. This is involving the mathematics. This is involving the algorithms that I was mentioning. So we can say that this is AI, and the skills that we were just mentioning, they're enough there. But then in the same time, next to this robot, I will say that the self-driving car is also AI. And now when I think about that, and when I think about the essence of those two, I'll be asking myself, are the skills that I just mentioned, these 5 core skills, enough to say that we built those 2 very separate AI examples? And I'll be probably wrong, right? Because to build a car, yes, to build the algorithm within the car, yes, we need this machine learning, we need the program, we need the mathematics, but also we need knowledge about cars, right? We need to understand how would that car work. And there is this ethical dilemma that could be found online about the behavior of the car. So what happens if the car crosses the street and there are pedestrians who are crossing, but like 2 sides, older people and then younger people, and then the car should make a decision. This is the algorithm, but this is also the essence of the car. This is the road. This is the way we are living. This is the community and our place in it. Then I'll go to the human robot. My knowledge about cars could probably help if the robot is driving the car, but probably I'll need some understanding and another skill, probably psychology, probably understanding how the mimics of the face could make this robot be more human-like. I'll be needing those skills to develop different aspects of AI. I'll be needing the rest as well. So now I think it's fair to say that the skills for AI have broadened, right? Now we have, again, the mathematics, statistics, of course, the computer vision, everything, but also cars and psychology. Now, if we think of the different artificial intelligence examples, we might add some additional skills there. And we might get to a point where we're talking about skills that we underestimate as necessary for AI. But if we go back to the definition of what's AI, this is our human intelligence and this is our human actions invested in the computing power. And if we say that we are only investing programming and analytical skills and mathematics and statistics, yes, this is right. Yes, we'll be able to do to create an algorithm, but all the different skills that we possess will help us enrich this and actually create a different example to be successful in a different way. Because sometimes, for example, the skill of drawing might help me create an AI in the area of drawing that would be extremely powerful and extremely helpful. But I will need this understanding. I will need to understand this skill to have this skill. And this goes further. Like, we can be talking about different examples. We can be talking about different applications within this is why we have AI within our houses. This is why we have it in chessmate, for example, in chess. This is why we have it in the cars. This is why we have it in all the different areas you can imagine. So we're talking here about a variety of skills, and those skills can be thousands. In its core, AI is about thinking, and AI is about understanding. The main skills that we need are these: thinking and understanding, and then thinking out of the box, thinking out of being a programmer, of being an AI person, thinking out of being a machine learning engineer, being an AI, and working in AI. In my experience, I've been a programmer. I've been working with machine learning. I've been working as sales, technology and solution sales for data and AI. I've been working as consulting manager, as strategist, like all the different areas. I've been also teaching this and now working from a community perspective. All these different aspects show you a different perspective of artificial intelligence. Now, think of the way you actually build an artificial intelligence. Think of the part where you're actually developing. Find yourself here. So the development, the programming, the machine learning I'll use in this example will be in the modeling part. But the path towards an algorithm contains many more steps than just the machine learning itself, just the coding itself. First, you need to understand, to have the business understanding, to set your hypothesis. What are you doing? Why are you doing it? What do you think will happen? Like, what are the hypotheses that you're building before you get to this algorithm, before you get to this model that you're building? In the model, you're using data, but how do you decide which data? Is it enough if somebody just gives you the data and asks you for a result? Is this the true value and the most value that you could bring if you can only program this? This is the second step, understanding the data that you're having, thinking out of the box. Do I need additional data? Do I need to think of additional sources? Is the data that I'm having valuable? Is it trustworthy? Could this help me? Then the data preparation part, of course. And then the modeling, evaluation, and deployment. Usually, people that are more technical within AI, they care about only the middle, about the preparation of the data and the modeling. But the true value of AI unveils when we are discovering and when we are going through all these 6 steps. Now, I'm not saying going in a waterfall process. This is the CRISP-DM model, and this is showing like all the different arrows that you can see. These are all the different loops. So this is one process that goes on. Sometimes when you're at your last part, evaluating your model, you may need to go back to the business understanding. You may need to see that the hypothesis that you've built is wrong, and you may need to redo that. Or you may think that there is additional data that's needed. So in the first part, between the business understanding and the data understanding, you first need to see, okay, I want to predict something, but I don't have the data, or I have more data, so I can predict many more things. This is the first interaction that we're seeing. Then the second one is between the data preparation and the modeling. And this is the pure technical part where, of course, I'm talking about the very important skills of knowing how to actually model the algorithm, knowing about mathematics, about statistics. This is the essential knowledge for that. But also understanding what's data and how powerful is that data. Then going through evaluation, and this is the point where you evaluate what you've done, whether what you've done actually answers the main question that you've asked, or that your business have asked you. And then deployment, and this is a cycle. And this is a cycle that will enable you further to come up with data-driven decision-making. And this is not only a phrase, this can define your sales, this can define the marketing, this can define your way forward as a company. We're talking here about the ethics, we're talking about the value of what you're building and the value of what you're creating with your algorithm. We're talking about applied artificial intelligence and automation. So building those, what you're creating, and then after this point, you'll be going back because it's a cycle. AI is not something specific that you just achieve with one code or with one model. It's a concept, and it's a way of perception and a way of thinking. And with everything that you're doing across these steps, for example, for the business understanding part, you may need additional skills, you may need additional knowledge, or you may need to ask somebody who has it. I'm not saying that an AI person should know it all or should be able to draw and sing and talk and drive a car, for example. I'm just saying that you should be open, you should be thinking of how to embrace this step and continue further. Now, only at this point, you can identify the skills that you need. If you're looking at certifications for AI, there are amazing certifications for AI that will teach you a lot of stuff, both technical and business-wise. But there is a basis, and there is general knowledge about data, there's general knowledge about the world, about the community, about what you're doing. That's essential. So your intelligence, your actions, your way of thinking is essential for what you're building afterwards. Otherwise, we can all relate to Joey, who, if you remember in France, has identified that when one of these skills that's essential for his career as an actor is drinking a gallon of milk within 60 seconds. So thank you very much. This was all for me. I'm open for questions, comments from your side.
Myself before talking to you. Thank you very much, Ekaterina, for this very insightful session keynote. We already had one interesting question from Alex from Germany, who was wondering what is the most difficult part to achieve: business understanding, data understanding, or modeling? Because he thinks some AI projects did not understand the business where to start. What is your thought about that?
Yeah, depends on the different projects in general, and depends who you're asking. If you don't have a person who has overlooked all of the 6 steps within this model, then they'll have difficulties in the different areas. The business understanding part is, in my opinion, the most important one when it comes to, because this is your starting point. This is the moment when you define what you want to build. This is the moment where you're setting your questions. And if you're answering the wrong questions, if you're building a model that's answering the wrong case and it's serving the wrong business case, then your results will be wrong. Then your modeling will be wrong. Then you'll be evaluating something that it might be the perfect code and it might be the perfect data, like all the technical work might be amazing, and I'm sure it will be amazing if you're a good one. But then if you're answering a wrong question, then what is the value of what you've done? Because it could be valuable only for people who look at the code. But if it's not valuable for the business or for the research question, it's often could be used for research. So I would stress on this part. Honestly, during my master's, I've been working on a project where from the evaluation part, we've realized that we are answering the wrong question. And we had to go back 4 months of work and really re-ask and identify what was the right one.
I think that's not only an AI project, it's in any software development. Is this actually the correct problem that we're solving? Yeah. That it might lead us to a totally different project. In one of your slides where you printed out all the different steps that need to be undertaken, there's also the part about ethics. Someone is asking on your slide, it was and one of the last steps, but do you think it's only something that needs to be looked at the end, or is it something we need to look at from the beginning already?
Oh, definitely in the beginning. Definitely in the beginning, ethics. There is this conversation and this paradox when we're talking about ethics and AI. So should we set the ethics constraints in the beginning, or should we talk about a framework in the beginning and then develop AI? Is this a stopper for AI? Or should we do first the AI and then we'll be talking about the consequences from ethical perspective? And this could go back and forth. In my opinion, those two, like ethics, should be everywhere along the AI path. It should be considered within every step that we're undertaking. I placed it in the end because this is the moment when we usually think about it. This is the moment when we think, okay, what I've built will have this impact. I've answered my question. Now let's see, is it ethical? So I have, for example, I have my model of predicting customer behavior. I can predict everything about them, but is it ethical to use it? Is it ethical to use their customer data into like, this is the oldest example ever of the supermarket and the pregnant woman that the supermarket knew before her family, but this is a very good example of this.
Yeah. Okay, thanks very much. What I noticed in your keynote that you were asking us a lot of questions, right? Let's say someone who has no AI skills at all and has that question like, what is AI? Where do they start learning these things?
Yeah, that's absolutely fair. The person should ask himself or herself, what do they want to achieve? Like, why are they looking into AI? And when you answer the question, why am I looking into AI, then they'll be able to identify those skills. This is why I talk that AI is about thinking. AI is about understanding this. For example, I started with data science. I started with machine learning. For me, it was extremely interesting of combining business and programming together. And I found that the most value I could bring is out of the data and out of building models. Then at some point, I realized that data, actually, if you go back to this data component, this gives you so much, like the different ways you can gather this data. And here you're going to cognitive services, for example, gathering data through cameras, analyzing this, image recognition, computer vision, like this is extremely interesting. Like right now, transcribing what I'm saying, my emotions, your emotions, being able to have this analysis right now of what's happening. And this is about thinking of the data sources, and this is post factum. So I was talking about the data science model, the data sources, and then getting into the AI aspect of this one. For me, a person, and I only got certified after a few years of AI when I was exploring all the different areas. And for me, a person should really start with understanding what is it, like what is AI? What is valuable for himself or herself? What do they want to do in the future? What do they want to build? And then based on that, do a little map of their own. Just think of like, these are the areas I want to cover, and this is how I want to develop within those areas. Because at the end of the day, again, artificial intelligence is our intelligence and our actions and our endeavors. Technology is out there. Technology will keep evolving, right? Well, like you can see Microsoft is exploding when it comes to AI, and it will be there to help. And we can learn about technology. We can read about technology. It's extremely interesting. It's amazing. And it's out there to help us. But to help us do what?
And would you also advise developers that want to start in the world of AI to focus on mathematics?
I think that mathematics gives you, first of all, for when you're talking about machine learning, and machine learning, it's in the core. It's in the core of computer vision, of image processing, everything. But when you're thinking about it, this is statistics. And if you're not a pro in statistics, then you should be able to understand what's the logic, understand what are the calculations. My opinion is that analytical thinking and mathematics in general, the way mathematics learn you to think, is a very helpful skill for AI.
Okay. Now we had one other question. It's more about, let's say we start in AI. What is your preferred programming language? Ekaterina, what should they start learning?
Mine is R.
Okay.
I know, because I'm only so it's Python or R, the biggest question. But Python is for programmers. R is for people who have more of mathematical knowledge, or who are more who have the analytical part but don't have the programming part yet that developed. I was a programmer. I was studying for a programmer. But yet, for me, R was the preferred language as I was feeling more comfortable with it, and it's very easy to understand, and even for people who are new to this, who are new to the technology and for the technical world, it's probably more understandable to go through that part.
Okay. Thank you very much, Ekaterina, for your thoughts, your keynote, and your ideas about AI. We'll see you back in an hour and a half during the panel discussion. But for now, we're going away for a couple of seconds, and we'll be back with another keynote speaker.
Thank you.
Hi, my name is Ruth, and I'm from New York City.
Hallo, ik ben Ben de Klerk uit Italië.
Bonjour, je suis Jean-Philippe Pancos de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hey iedereen, ik ben Sammy uit België.
Cześć, tu Bartosz Polski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan， 来自台湾。
Lebanese kelemu abum Pascal juduzi alemezi.
And we're back for another session. And Francesca is joining us, and she's going to talk about ML Ops for continuous learning. Hi, Francesca. How are you?
I'm great. Thank you. Thank you so much for inviting me. I'm very excited to be here today and talk a little bit more about MLOps, machine learning operations for end-to-end solutions on the cloud. Can I share my screen, or please let me know when I can share my screen?
Now, first, I want to ask you if you can introduce yourself for a bit before we start, and then the floor is yours.
Absolutely. Thank you so much. Yes, so my name is Francesca Lazzari. I work at Microsoft as a principal data scientist manager. And at Microsoft, I lead a few teams of data scientists and machine learning engineers. And we work actually with internal customers. So we work with the Microsoft data, and we build end-to-end machine learning solution to support different business areas at Microsoft. I'm also an adjunct professor at Columbia University, where I teach machine learning. And yeah, that's pretty much about me. I'm based in Boston, Massachusetts.
Okay, sounds like you have a very cool job.
Yeah,
yeah.
I think so. I feel very, very lucky, actually. So yeah. I do think that my job gives me the opportunity, first of all, to work with a lot of talented people. That is, the best thing I can ask for. And second, of course, I'm always exposed to many different problems that can be solved with data. And so really the role of my teams and including myself is really to look at these different data sources, data pipelines, and try to understand if there are better ways to extract knowledge, to extract insights from that data in order to improve our customer experiences on the cloud.
Yeah, yeah. Sounds cool. Okay, so are you ready?
I'm ready, of course.
Okay,
Thank
good
you.
luck.
I just wanted, to test the Teams and see if it was working. Let me start sharing my screen.
Okay.
And let me know when you can see it.
Yes.
Great. Okay. So
yeah,
let's get started and let's learn a little bit more about MLOps for continuous learning. As I said before, my name is Francesca Lazzari. I also added here my Twitter alias, so feel free to also reach out after this session if you have any questions on machine learning, data science, MLOps, and the cloud. But let's look together and let's try to understand together why it is so important nowadays to talk about machine learning operations, that is MLOps. So there are a few reasons why it's important to think about machine learning operations not just as a tool on the cloud that customers can leverage in order to have an end-to-end solution that is sustainable and scalable. It's not just about that, but it's actually a cultural mindset that you need to actually establish in your in your teams, in your organization. So as you know, there is the machine learning life cycle has a lot of limitations, and there are also a lot of opportunities in terms of data, model parameters, features, monitoring, and also debugging. Machine learning models rely on a huge amount of data, and it is very difficult for a single data scientist in your organization to keep a track of all of it. And also in terms of model parameters, it's very difficult to keep track of all the parameters that we tweak in machine learning models. Then in terms of features, data scientists need always to keep track of the features for their models, machine learning models, and then monitoring. Monitoring a model isn't like monitoring a deployed software or web app. And so there are additional tools that I want to share with you today, and more like tips and tricks that you can leverage in order to improve the monitoring of your deployed and operationalized models. And finally, debugging, troubleshooting, of course, models, machine learning models when they are not really performing, and it's a very complex scenario. And so there are again some tools and a set of open source also framework that you can use in order to debug quickly your machine learning models. First of all, let's try to understand what are the different machine learning operations capabilities. And then together we will look at the open source integration, the machine learning pipeline, and the ML flow, which is a very powerful tool that you can use in order to build these MLOps culture and a set of tools in your organization. So let's start with machine learning capabilities. First of all, when you think about machine learning capabilities, you need to understand that it is important to create reproducible, scalable machine learning pipelines, because machine learning pipelines allow you to define repeatable and what I also call the reusable steps for your data preparation, training, and scoring processes. Then you have to also create reusable software environments for training and deploy your models. The other important aspect that you need to be aware of is that you need to know how to register, package, and deploy models from anywhere. And you can also track associated metadata required to use the model. And this is going to help you then with the debugging part of this cycle. And then it's also important nowadays, of course, to capture the governance data for the end-to-end machine learning life cycle. Notify and alert on events in the machine learning cycles, and finally also monitor machine learning application for operational and machine learning related issues. So this is what I called machine learning capabilities. It is a set of capabilities that you always need to think of every time that you deploy and operationalize any machine learning model on the cloud and also in your own environments. The second part that is also extremely important is to be exposed to open source tools and how you can integrate those open source tools with your own environment. So let's try to understand a few set of tools that I have been using now for a while, and I found them like extremely helpful. So there is the training of open source machine learning models, frameworks for interpretable and fair models. And finally, there are some open source tools that you can use for model deployment. Let's start with training open source machine learning models. There are three frameworks that I have been using a lot for different machine learning solutions that I build. Those are PyTorch, TensorFlow, and Ray. Probably you are all very familiar with TensorFlow because it has been around for a while, but in the last few years also PyTorch has become like one of the tools that the data scientists and machine learning engineers really love in order to build their scalable machine learning solution. And then Ray. Ray is reinforcement learning. But let's start with PyTorch. PyTorch is an end-to-end machine learning framework, and it's great because there is this torch serve that is the core of PyTorch and is an easy-to-use tool for deploying PyTorch models at scale. And the PyTorch is very nice because right now it's very well supported on multiple cloud platforms, and it's great in order to also build solutions that are like a little bit more advanced deep learning solutions. There is a TensorFlow. TensorFlow is extended is an end-to-end platform for preparing data, training, validating, and deploying models in larger production environment. There is this TFX pipeline that is a sequence of components that implement a machine learning pipeline, which is specifically designed for scalable and high-performance machine learning task. And finally, I was mentioning Ray. Ray is great every time that you are building a solution that is based on reinforcement learning approach. In terms of libraries, there are many different libraries for taking machine learning and distributing apps to production. So it's a great tool, open source tool that you can leverage again when you need to develop reinforcement learning applications. In terms of fairness and interpretable machine learning, these are, of course, a concept that are right now extremely important in the machine learning field, because, of course, you as a data scientist, but also as a final consumers of machine learning, consumer of a machine learning application, you want to be able to understand why your machine learning applications are producing specific results. And also you want to make sure that you are able to implement those tools that are telling you if your solution and the data that you're using for your solution are fair. And so there are two open source tools that I have been using a lot for our own applications. The first one is InterpretML, which is a package that incorporates state-of-the-art machine learning interpretability techniques. And with this package, you can train interpretable glass box models and also explain black box systems. And then there is a FairLearn. FairLearn is again another open source Python package that has two main components. The first one is around the metrics for assessing which groups are negatively impacted by a model, which groups of also users and customers. And the second one is about algorithms for mitigating unfairness in a variety of AI tasks, along with a variety of fairness definitions. So again, make sure that you always incorporate those packages as really part of your data science lifecycle or machine learning lifecycle. The third aspect that I wanted to share with you today is related to model deployment. Of course, every time that you train, test, and validate your model, then you need to pick the best model for your solution, and you need to operationalize this model. And this is extremely important for data scientists, for machine learning engineers. And so one open source tool that is really helping right now data scientists and machine learning engineers with this aspect of the life cycle is Onyx. When you as a data scientist, you're working with different frameworks and tools, it means that you have to deploy models according to the framework's requirements. And to standardize this process, you can use the Open Neural Network Exchange. This is Onyx. That is a format that is really helping you with that. You will always find yourself in situations where you're working on a solution and you're using multiple frameworks. And Onyx is going to be that type of connector that is going to allow you to deploy your models. So what is specifically Onyx runtime, what we call also ORT? Onyx is an open format built to request machine learning models, and Onyx defines a common set of operators, the building blocks of a machine learning and deep learning models, and a common file format to enable developers, again, data scientists, machine learning engineers, to use models with a variety of frameworks, tools, runtimes, and compilers. Specifically, inside Onyx, there is the Onyx runtime, that is, as I was saying before, ORT, that is there to optimize and accelerate machine learning inferencing and training. So as you can see from the next slide, it's really great because it's a framework that is freedom, that allows you as a data scientist to have that freedom with a common interface for multiple deployment targets. Converting to an Onyx model is really easy independently from the different framework that you are using. Again, I have been working with data scientists who have been using TensorFlow, Keras, ML.NET, MathWork, PyTorch. Before, in the previous slide, I was showing you the three main open source frameworks that I have been using, like PyTorch, TensorFlow, and Ray. But honestly, there are so many others. And then when you get to the model deployment, to the model operationalization, the conversion that you can do from these frameworks to the actual deployment of your model is actually pretty easy. Here, I share with you a few examples on how you can implement this model conversion. As you can see, you can take either Keras or PyTorch, and then with just a few lines of code, you can just load the model and then convert the model into, like depending on the frameworks that you are using, and then also you can export the model so that you can have that file that is containing your model deployed. So Onyx is really probably the tool that I use now the most when it gets to machine learning model deployment and operationalization. Moving on with our MLOps for continuous learning cycle. So we saw the MLOps capabilities and what I mean when we need to learn those capabilities in order to be able to implement them once we deploy our machine learning models. We saw a few open source integration options in terms of tools that you can use from model training, and also machine learning fairness, machine learning interpretability, and then the deployment of your machine learning model. And now let's look at another important concept that you need to be exposed to if you want to implement MLOps strategy in your data science organization. This other concept is extremely important because data preparation, including importing, validating, and cleaning transformation of your data, needs to be done inside this machine learning pipeline. And training configuration, including the parameterization and also the inclusion of arguments, file paths, and logging configurations need to be part of these machine learning also pipelines. And then machine learning pipelines need also to include and to think about training and validating efficiently and repeatedly your models. And finally, these include also the deployment of your machine learning models, including versioning, scaling, provisioning, and access control. So these are really the set of tasks that the pipelines should look at when they are created, because from data preparation to training configuration, of course, you need also to training and validate your model, and finally, you need to deploy your model. All these steps are part of what we call the machine learning pipelines. Very often when I work with customers, they always ask me, which pipeline technology should I use then? And so that's why I created this simple table where you can see that there are different scenarios, of course. And here I tried just to summarize some of them. Some scenarios, for example, for model orchestration that is really focusing on machine learning. The primary persona for this is usually a data scientist, and the open source offering that you can use is Kubeflow. For the second scenario, as you can see, there is a data orchestration. The primary persona for this is the data engineer, and one of the open source offering that I have been using a lot is Apache Airflow. And finally, for code and application orchestration, that is more CI/CD, this is the persona, most of the time, the persona that is actually working with this scenario is an app developer. And I have been using a lot Jenkins. And again, depending on the specific scenario you find yourself in, and also the type of professionals you're working on, there are many different open source tools that you can use, you can leverage in order to build your machine learning pipelines. The last concept that I want to introduce today for the MLOps for continuous learning cycle is called MLflow. MLflow is both a concept, but I would say is also a tool. Is another tool that I have been using a lot for MLOps capabilities, and it is a tool that is based on 4 different components: MLflow tracking, MLflow projects, MLflow models, and MLflow registry. Let's quickly see all of them. So MLflow, as I said, is an open source platform for managing end-to-end machine learning lifecycle. It tackles 4 different primary functions. The tracking experiments to record and compare parameters for results, and also in order to improve the results that you are getting from your machine learning models. Then there is also the different MLOps tracking capabilities. This is more like an API and a UI for logging parameters, code versions, different metrics, and different artifacts when you're running your machine learning code, and for also later visualizing the results that you're getting from your machine learning models. MLflow projects, these are a standard format for packaging reusable data science code. And it's very nice because each project is simply a directory with a code or with a Git repository. So it's really great when you want to reuse your data science code. Then you can see that there is a MLflow models. These offer a convention for packaging machine learning models in multiple flavors, and also is a sort of a variety of different tools that help you to deploy your machine learning models. And then finally, there is the MLflow registry that offers a centralized model store and also a set of APIs and UIs to manage the full life cycle of your machine learning model. So this is again a great set of 4 different steps that you can use in order to implement end-to-end machine learning solutions, and also be able to maintain those solutions from an operations point of view. Finally, I want just to leave you with a few references. Here, there are a few great articles, resources, and also all the open source tools that I share with you today. And so if you want to learn more, for example, about Fairlearn, InterpretML, Onyx, here you find all the resources that I use for my work and also for this presentation. Thank you very much. I hope you learn more about MLOps capabilities, and please let me know if you have any questions. Thank you.
Thank you so much, Francesca. Great presentation. Really, I learned a lot from it. We have a couple of questions for you. The first one, is Onyx recognized by typical registry servers such as MLflow and Azure ML?
Yes, it is. This is actually a very good question. The fact that I started using Onyx a lot because it's very well integrated on Azure machine learning. And so you can use it honestly anytime that you're using a Python-based framework for developing your machine learning, deep learning solution. Then when it gets to the deployment of your machine learning models, you can use Onyx, and so you can be on different clouds independently from the the cloud provider that you are leveraging for your solution. You can use it, and I personally have been using it a lot on Azure, and so with Azure machine learning. This is a very good question, and it's probably one of the first questions I asked to the product team that was introducing this integration. Because I'm really keen about using open source tools also on the cloud, and so that is one of the reasons why I start using Onyx.
Okay, so it's very well supported across different clouds, yeah. And okay, sounds good. Which basic models can we learn if we want to start a career in AI?
Wow, this is another great question. So I would say if it depends a lot on the type of role that you want to have in the AI industry. I would say that at the beginning, when I started more than a decade ago, in working data science, machine learning, AI, you had to be like a data scientist. So you had to be a person with a strong statistics and mathematical background, and you had also to know how to code in R, Python, also using like SQL for the ingestion of your data. However, nowadays there are multiple roles that you can actually get if you work in the AI industry. I'm thinking about machine learning engineers, data engineers. I'm also thinking about machine learning researchers, data scientists, of course, but also product managers that are, more like the people who help develop the tools that data scientists and machine learning engineers are going to use. So I would say it really depends on the type of role that you want to have. If you ask these questions specifically for data scientists, I would say they really start with learning very well how to use Python for machine learning. And after that, you learn like how to build simple models. I will always recommend my teams of data scientists and machine learning engineers to start with simple models like regression, classification. But then the most important part is really about getting familiar with those frameworks that are right now used a lot in the industry to build machine learning models and solutions. I mentioned some of those today, like TensorFlow, PyTorch, Ray. And the more you get used to those frameworks, the more you will learn how to tackle some of the most complex problems with the data and build your solution on the cloud. Yeah, so that is my recommendations for you.
Very good recommendation. I think I will follow that one as well to get more into it. Thank you. We have one more question. If you want to start with ML Ops in your organization, what profiles do you need to add to an ML Ops team? Because I see lots of customers struggling with this.
Yeah, that's another great question. I would say that, today I hope that with my presentation you got a very good overview of what are the options that you have as a developers, as a data scientist to implement a MLOps strategy around your organization, around your data science solutions. However, I understand that it depends a lot on the type of problems that you're trying to solve. So always try to think about MLOps again as more like a cultural environment, or like I would say probably a mindset that you need to establish across your organization. MLOps is not something that can be done in a silos by just one or a few data scientists, but it's really a cultural change that you need to establish across your organization. And so start to think about machine learning not just as a machine learning model in a Python notebooks, but start to think about machine learning as an added value to the business or to a specific scientific areas that you are contributing to. Because if you think about machine learning in this way, then you are going to think about AI application or machine learning solutions as real tools that can improve our life, which is totally true. And so if you think about this, you immediately start thinking about how I can make sure that those models stay accurate. There is, of course, a refresh of the data and can consume the results from those models over time without spending too much time debugging, refreshing, or like manually improving them. So if you start to think about the life cycle and the real life of a machine learning models, then you will start thinking about the tools that you can use in order to make sure that that life cycle is supported over time. And by thinking in that way, then you will try to find like some of the tools that are the best tools for your own use case. Again, it's possible that you're working already with TensorFlow, with PyTorch, with Ray if you're in the reinforcement learning field. And then based on those frameworks, you will need to find a tool that is helping with your deployment, and that can be Onyx. And then some of those additional tools like MLflow that are helping with also packaging the model or helping with the registry of your model. So think really about the end-to-end life cycle, and based on your specific scenario, of course, there are the best tools that you can use and think about how you can connect all of them to maintain the life of your model. And so if you think, I think in that way, also the potential of your machine learning models then are really not going to find any limits, because you want those machine learning models to be accurate, but most important, you want them to be scalable and extensible also to other scenarios that you can support over time.
Yeah, yeah, totally true. Yeah. We have a couple more questions. Let me check.
I think we'll need to start going to our next speaker also.
Is it already time?
Yeah, it's time.
Oh, okay, okay.
But yeah.
We have some questions in the chat. Are you available to answer them after this session?
Yes,
okay,
I think
that would be great.
Yes.
Okay, thank you.
Thank you so much.
Thank you so much for your session. Really interesting.
We will see you back in an hour at the panel discussion.
Okay. So we will be back in a bit with our next session.
Hi, my name is Ruth and I'm from New York City.
Hallo, ik ben Ben de Klerk uit Italië.
Bonjour, je suis Jean-Philippe Pancos de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hey iedereen, ik ben Sammy uit België.
Cześć, tu Bartosz Mikulski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan， 来自台湾。
Abum Pascal, Judy Alemisi.
Hello. Hi, Eric. Good morning to you, if I'm correct.
Yeah, it is morning here. Yes, thank you.
We're still waiting for Beatrice to join us.
Or maybe...
Here I am.
Oh,
yes.
there you are. Yay. Good morning to both of you. How are you guys doing?
Doing well. Nice weather in Seattle today.
Oh, you're both in Seattle, right?
Yeah.
Yep.
Okay. Same time zone. Could you please introduce yourself? Let's start with Beatrice. Who are you? What do you do at Microsoft?
I'm a cloud advocate at Microsoft, and my role focuses specifically on Azure ML, which is now my favorite Microsoft product. And I have a background in Azure machine learning, both in grad school and at work. So I've been doing it for a little while. So that's basically what I do.
Okay, cool. Eric,
and
what about you?
I'm Eric Boyd. I lead the AI platform team, so including fabulous products like Azure Machine Learning that Bee loves so much, as well as our suite of cognitive services, the work we do with OpenAI, and all of the things like that.
First of all, Eric, we also need to thank you for joining us like every big event we organize. We really appreciate that you make time for us again. And
Always
I need to ask you,
about,
can I get some more GPUs,
AI.
please?
Sorry, what was the question?
I need to ask the question, can I get some more GPUs?
Don't make me update my sign.
All right. The keynote that you guys are going to give is Azure AI Innovations at Microsoft. Well, I would say the platform is yours, and we're looking forward to learn more about what Microsoft is doing.
Yes, good luck.
Great. Well, let me go ahead and share my screen. And hopefully that worked for everybody.
Yeah, we see your screen.
Yes.
Excellent. So I just want to talk a little bit about, what we're doing with Azure AI and some of how all this stuff works and comes together, and, talk about really how the mission, our work, the different services we have, and how we bind that all together with responsible AI. And so without sort of further ado, maybe I'll just jump right into it. We love to start with this mission that Satya's laid out for Microsoft, this bold mission of empowering every person, every organization on the planet to achieve more. And within the AI platform organization, we think about, how does our mission really dovetail that? And, we have a mission statement, but put really succinctly, we see AI as changing the world, and we want to make sure that we can enable everyone to go and take advantage of that. And so we really see the impact that this is having on the entire planet as being really profound. And it's very exciting to see, but that's, AI is just really transforming so much. And so I wanted to spend some time talking today just to highlight some of the places we're seeing AI show up in different businesses and some of the cool things that you can do with the tools and technologies that we've got. But for us, it always starts with research. And so that's one of the things that Microsoft has been tremendously fortunate in. We have Microsoft Research is the leading AI research lab in the planet, really all around the world, thousands of researchers, lots of patents and papers, regularly pushing the state of the art in AI. And that state of the art, really shows up in a ton of different products and a ton of different fields where we've really been, getting to human parity, which is just a milestone that we choose in a lot of different areas, from, object recognition to image captioning to natural language understanding, really all across the board. And, one of the things that we really focus on in the AI platform team is how do we take these breakthroughs, which show up in a research paper, on often a sort of lab environment that's not particularly stable, how do we get that into our products and get that into hands of our customers and really use it to change all of the businesses that we want to impact out there? And so just to take one, image captioning, the paper was published in about March of 2020, saying, hey, we've got some new breakthroughs, and with these large language models and understanding images, we're at human parity in March of 2020, according to the benchmarks that we measured on. We got that into our products in the APIs in like 3 to 4 months later, basically taking the research model, hardening it, giving it all of sort of the Azure goodness, all of the things that people expect around enterprise readiness and stability and quality. And, now it shows up in products like Designer, where in PowerPoint, anytime you sort of put an image in there, will auto caption the image for you, giving alt text for it if you don't bother to do it yourself. And so that type of turnaround time and that type of impact really, and it shows up in, not just in PowerPoint Designer, but PowerPoint Designer, what is it calling? It's calling the, Cognitive Services API. So that same thing available to our third parties. And so we spend a lot of time thinking about how do we take this really rapid pace of innovation that's coming out of the AI research community and get that built into the products that we want to go and develop. And so when we think about Azure AI, we think about it really as this layer cake here. We're all built on top of the foundations of Azure. So we have access to the world's largest cloud supercomputer and all of the, GPUs and CPUs and everything that's available there. And at the base level is Azure Machine Learning. And so that's a tool that we'll talk a bit more about, but really helps you manage your models, deploy your models, manage the full ML ops lifecycle of them, train the models, get access to thousands of GPUs, manage the sort of the training iterations that you're going to need to go through. And so it really is the tool for helping machine learning scientists and developers build their models. And so the next layer up of the stack is our suite of cognitive services. And so these are models that we at Microsoft have built in vision, speech, language, decision, and of course, our new partnership with OpenAI, which is showing up increasingly in new and exciting services. So these are models that are really state of the art that you can call as a cognitive service, a web API directly. And it really simplifies the process of getting AI into products. For customers who, they don't want to build the expertise and all of the training data needed to build a high quality speech model, they should just call the cognitive service and they can add speech recognition or text to speech into their products in a matter of minutes. And so making it really simple to do the things that you need and have the impact on your products in a really quick and easy way. Then the top level of our services is our scenario-based or applied AI services. And so the thinking here is to say, we've got a number of ingredients at the cognitive services level, but those ingredients are often used in some very common use patterns. And so let's make those common use patterns a bit more productized and easy to consume. So, just as an example, in the vision cognitive service, there's optical character recognition. So given, a sheet of characters, you can turn that into text. But what people usually want to do is not just turn it into text, but actually take a form that they have and get the key value pairs out of it and put it into a database. And so that's what Form Recognizer does, is it wraps the OCR process that we have in Vision, but makes it really simple for you to, quickly with a few examples, get a form recognizer that will recognize the form that you have and then enable you to extract the data and put it into the data stores that you need. And so making that very common use case very easy to do. And so that's how we think about the services at that layer. And of course, these services are really geared for, the developers and data scientists. But at Microsoft, we serve a wide variety of users, so all the way through business users as well. And we integrate these services into other products across Microsoft to make them more easily consumable by anyone. And so from everything from Power Apps, which provides a low-code, no-code way to build applications, which can then call all of these different services, all the cognitive services through an AI builder layer, as well as, then we integrate these services into other products. So like Power BI can directly call and train models on Azure Machine Learning and can use the models that others have trained for you, all the way to the full suite of Microsoft products. These services show up all across Microsoft in Microsoft 365, Dynamics, and all across the board. And that's one of the things that gives our customers a lot of confidence, is because Microsoft runs on AI. Like we build these services for ourselves and we use them for ourselves. Something you won't hear our competitors saying as much. The Office team builds all of their models directly on Azure Machine Learning. That's the tool that they use to build, train, deploy, manage all of their work. And so when they want to do something like predict the text that should appear next in a Word document or an email, that's done on models that are built and trained using Azure Machine Learning. And all the way to, Teams calls, we transcribe the text. And so you can turn on transcription, you can turn on translation, you can turn on real-time translation. That is calling cognitive services directly, the same ones that are available to our customers. And so when we can make these services this rich and this mature, Translator embedded in Edge has just, millions and millions of users. And so to be able to trust on these services being called by these high-end, services for Microsoft, that really gives our customers the confidence that these are services that are really enterprise grade. They're ready for the enterprises because we've made the same bet on them. And so if we're trusting our business to it, we expect our customers should be able to trust their business to it as well. And so it's not just Microsoft that's transforming, it's really every industry. I sort of talked a little bit about this. We're seeing the power of AI just touch every single business and every process and everything that gets done out there in the world, which is really exciting to see. It's a great opportunity, even in a time now where we see some, economic pullback and companies are sort of reassessing like some of the investments that they're making and how they're thinking about it. AI is so often a cost saver for companies that those projects tend to be ones that they still want to go forward with, and they want to find ways to use AI because it can provide value and it can save them costs at the same time. Some of the things that we see, we've worked across almost every industry, right? In financial services, we'll work with companies on everything from detecting fraud to making better and easier forecasts for all the different dimensions that they want to work at. Retail, we can help personalize objects, items to each individual user using a personalizer or building custom models for people. Healthcare, there's a ton of work happening in healthcare, both through our partnership with Nuance, our now company that we've acquired, Nuance, as well as sort of other companies that we partner with, across the spectrum. So all across the board, we just see these changes coming in industries, and I get asked all the time, I'm a company and I'm starting to get started in AI, and how do I really get moving and how do I get going with it? The helping people understand what are the use cases, what are the common areas that are really going to help their companies really move forward. I think that's a really important thing that, we as a company and as an industry need to help these companies figure out, because AI is going to be so transformative in all of the work that they're doing. So some of the most common adoption patterns that we see when we go and talk to these customers, these are just a few of the examples that we see, but a common pattern is knowledge mining. So this is the notion that companies have just amazing amounts of data in all of their documents, all across the enterprise. And it's usually locked up and hard for them to find. Sometimes it's not indexed, or maybe it's even, a PDF file that they don't have a text version of, and invoices that they have over the last decades. And so how can we use knowledge mining and Azure Search to really help crack open all of the insights that they have in their business to be able to get insights back out? And so an example is Icertis. We work with them. They're trying to track their compliance through their compliance costs through their supply chain, tracking all these different steps. They have all the different documents around it that to support it, but it was very hard for them to get insights into it. And so by using a knowledge mining solution on top of cognitive search, they were able to really get insights into how to do this effectively. We see a lot of business process automation. So I talked about the way we use Form Recognizer, the number of businesses that have paper forms that they need to process, and so we worked with the National Health Service in the UK, and they have all these documents that they needed to process for their prescriptions every month. And so being able to give them a way to really speed up the way that that's done both makes them much more effective, as well as saves them a ton of money, because they can do these things so much faster. Machine translation is another really powerful area that we see. We worked with Volkswagen, and Volkswagen has documentation that they have in over 40 different languages. And so they were able to use machine translation to really cover the bulk of the translation needs that they had, only needing to sort of spot check and fine tune in a couple different places with human translators behind it. Again, tremendous cost savings for the company, as well as tremendous acceleration in their ability to go and get work done. Another interesting area is just how companies are finding data that's been locked up in things like their customer support logs. And so Allstate used speech transcription of their claim calls, all the customers calling in about the claims, and they both now use that to speed up what the claim processor is doing to sort of quickly get up to speed on, hey, what's going on in this claim, as well as they can get analytics on it. You can now run these large language models to understand what's being talked about inside of it, and really learn the ins and outs of it. So a lot of adoption across a tremendous number of industries. Really, the imagination of everyone is the limiting factor here of how much can be done. So very exciting to see. So I wanted to talk a little bit more about the suite of cognitive services and some of the ways that they can be used in your businesses. And so, the suite of cognitive services, speech, language, vision, decision, these are the sort of the core pillars that, really with a lot of richness and depth in them, that are state of the art across the board, regularly winning competitions, head-to-head bake-offs. This is generally the best that you can do in these particular areas. And so what I wanted to do is play a demo where Xiaowing is going to walk through some of the use cases that you might see and want to use these really around a customer support area. And so I'll just go ahead and play that.
In Bank of Contoso, their support agents receive hundreds of letters and emails from their customers every day. Here, I have an example of a dispute email submitted by an unhappy customer with their banking experience. A dense email like this can be tough for agents to catch up quickly, which will impact agents' issue resolution time and their customers' experiences. To resolve this challenge, developers in Bank of Contoso quickly put together this app using document summarization in Cognitive Service for Language. It provides agents with two types of summaries: an abstractive summary to rewrite a long email within only a couple of sentences, and an extractive summary to highlight a couple of key sentences from the original email, just in case the agent wants to get more context. Now agents can easily identify the reported issues with key information from long documents and quickly respond to customers, classify, and create case records. Now let's move on to another use case of contact center. Let's say this same customer also submitted a picture of paper form for this issue. The form is handwritten with customer details, so it can often take agents a lot of time to manually input the data into the system. And it could also result in human error. This is where Azure Form Recognizer can help you. The best way to try this out is using Form Recognizer Studio. Let's try to analyze general document and upload the form. By simply clicking the Analyze button, Form Recognizer returns the extracted key value pairs in the form. With this, the agent's manual process can be completely automated, so their time is freed up to focus on engaging with more customers. Now the same customer also made a phone call to the Bank of Contoso contact center. Hello, thank you for calling the Bank of Contoso. How may I assist you today?
Hi there. The abuse of my credit card has really screwed me up. I've sent the dispute email, I submitted the form. How long do I need to wait until it can be removed from my account? Please help me, and I need this solved as soon as possible.
I'm so sorry this happened. Let me assist you on your credit dispute request. It seems the customer is very upset about this issue. At this point, customer service managers probably want to get timely insights from a support call like this. So let's see how NLP capabilities in cognitive service can help you. Let's try it out in the Language Studio. It now provides a guided experience for developers to quickly explore and apply call center analytics. Using the sample data provided in Language Studio, we can see, together with cognitive service for speech and language, a call recording can be automatically transcribed and analyzed with sentiment and PI detection. It also uses conversation summarization to recap the customer issue and the resolutions as discussed in the call. Language Studio also provides the sample code and the JSON output. So developers in Bank of Contoso can easily get started with the sample code and integrate all these AI capabilities into this app to analyze the customer call we just played. With all these insights, service managers can quickly identify which calls need more attention and understand the content of those calls without even listening to the entire recording.
Really powerful to see how all of that can come together. Really exciting to see all those capabilities show up, and that's a sample application, but really helps you envision the types of things that really could be done with it. And the cognitive services really are a great asset to get you started and get you moving with that. I want to move from cognitive services into Azure Machine Learning. As I said earlier, this is sort of the base layer that helps you, build, train, deploy your models, manage them, manage the data, monitor them, and really watch the full MLOps lifecycle of it. It's really a very comprehensive suite of tools and a really powerful set of things that you can do. But more than talk about it, I think you would probably be in a better position to just walk people through and show them all the amazing things they can do.
Thank you, Eric. I will do just that because today I'm going to be demoing a game. That's right, a game. So more specifically, we'll be looking at the code for a part of a rock, paper, scissors game that uses AI extensively. And this code uses my webcam to capture an image as I make a rock, paper, or scissors with my hand, and then it uses AI to classify that image. And if you watch the Microsoft AI show, you may already be familiar with this app. So there are 3 parts in the development of this app. And in part 1, I'm going to be training the model locally on my machine. In part 2, I'm going to be training the model in the cloud using Azure ML. And in part 3, I'll be showing you a web app that we use to interact with the trained model. So let's just look at the code.
Let's start with step 1, where we'll be training the model locally. We're using a pre-trained ResNet 18 model. The inputs to our model are images that look like this for rock, this for scissors, well, you get the idea. And the labels for the images come from the name of the directory where they're located. We're using the PyTorch deep learning framework, the PyTorch Lightning package to reduce the amount of PyTorch code we need to write, and the MLflow open source package to log some parameters and metrics. I'll show you later how to look at these logs. We can run the training code by choosing the PL trainer launch configuration and pressing F5. Training takes a few minutes, so I use the magic of video editing to skip forward to the final result. You can see here that training was done over 7 epochs and achieved a very low validation loss and a validation accuracy of 1, which is perfect. We can look at our MLflow logs here. For example, let's look at our validation loss over the training epochs. Or instead, we can look at the nice UI that MLflow provides us to see the same information visually. I always like to test my models locally before I train them in the cloud, which we can do in this app by running the PL tester launch configuration. This tests our model using just a few images, so it should be pretty quick. And as you can see, our test loss is also very low and our test accuracy is 1. This is great.
Okay, so we saw how to train the model locally. And now in step 2, we're going to be seeing how we're going to be training that model in the cloud using Azure ML. And to use Azure ML, we generally have to create several Azure ML resources to be able to get things working in the cloud. And there are generally 3 ways of creating those resources. We can use the Azure ML Studio user interface if you prefer to use UI. You can write code using the Python SDK, or the third way is to use YAML configuration files and the CLI. And this is what I'm going to be showing in the next demo. This is the third option, using YAML files and the CLI. So let's look at that code.
Let's look at the YAML file containing the configuration for my data, which, as you can see, points to the location of my local data folder. I can upload this data to the cloud and create the corresponding Azure ML data asset by invoking the azml data create command in the CLI. Let's verify this using the Azure ML Studio. And there's our data asset. We need to create a few more cloud resources for our scenario to work. We could create each one individually in the terminal as I just showed you, but instead, we created a GitHub action containing all the CLI steps, which makes them much more easily reproducible. The GitHub action creates a job that runs my training Python file in the cloud, then it downloads the trained model produced by the job, then it registers the model with Azure ML, and finally it creates a deployment and endpoint we can use to query the trained model. Let's run it. I'll fast forward here. And when it's done, we can go to the studio and take a look at our training job. You can see here nice visualizations for the MLflow parameters and metrics we logged earlier. We can then go to the model section and see that our model was indeed registered in Azure ML. And finally, let's verify that our endpoint was created. And it was. Great. Now let's test the endpoint. Our input section is already populated with a test image, and our prediction is scissors, with really high confidence. Excellent. We're ready to move on to step 3, where we'll query our endpoint from within a web app. We're using an Azure static web app here, with an Azure function that does a post request to the endpoint we just created. Let's look at the web app running. I'll capture an image, and then I'll submit it. This triggers a post request, which passes the image I just captured to the endpoint and gets back a prediction, rock, which is correct.
And that's it. So we're making really good progress on our game. And as you saw, machine learning made it so much easier to achieve what we wanted to do. So thank you for watching, and back to you, Eric.
Thanks a lot, B. Really cool demo. Yeah, rock, paper, scissors. Obviously not the most advanced AI game, but pretty cool to see how you can use AI in lots of different places. So thanks so much for walking us through that.
Baby steps, right? You can't do a big game before you do a little one, right?
You got to be able to do rock, paper, scissors before you can do tic-tac-toe, right? We're building our way up. So. So next up, I wanted to walk through some of the things that we've seen coming with OpenAI. Really, there's been a transformation in the way that models are getting done, where it used to be a single, simple model just built for one purpose, to now we're seeing these large foundational models that are really generalized to a lot of different approaches. And we've seen the rate of growth in these models just exploding. I mean, GPT, which was released in 2018, to GPT-2, to GPT-3, and just really exploding the number of parameters. And the reason we're seeing so much growth in it is because the performance continues to improve as you make the models bigger, which has been really exciting to see. So we partnered with OpenAI, and with them, we've made GPT-3 available, a very large model used, generating lots of words every day with lots of different apps using the things that you can do on it. Very powerful AI, particularly in the, very powerful natural language modeling and understanding model. And so really great to see that used. We also used it to build GitHub Copilot, which instead of being trained on just English and language was trained on code as well. And so Copilot, as I'm sure most of you are aware, given a sort of a comment about, hey, here's what I want to write, and a function header, then you can generate the entire code. And we're seeing developers have, up to 30% of their code check-ins come just directly from Copilot. So tremendous efficiency being unlocked. We've also, with OpenAI, we just released DALL-E 2, which is now available in Azure OpenAI Service. And DALL-E 2 is a model where you can really take the text to get a model out of it. And so for someone who's not very artistically inclined like myself, you're able to get a lot of really interesting things done, and it's been integrated into Microsoft Designer, a product in PowerPoint, where you can see that DALL-E 2 is integrated directly right in it. And so what you do is you come up with the image, the background that I really want in my PowerPoint, and I just describe it. I want a Van Gogh of a bear eating a pizza in a restaurant. And you ask DALL-E to generate it, and it generates these really fantastic images that you can then sort of select which of these images do I want and use that for the base of my PowerPoint style and how I really want to develop and use that. But of course, all of these things need to be done in a responsible way. There are lots of things that you can imagine that could cause challenges with this. And so we've spent a lot of time thinking about responsible AI, really based around the core principles that we have and making sure that we're developing our models responsibly, reliably, safely, transparent, private, secure. Those are all the things that we really ingrain into our developers. And we provide tools as well. We recently released the Responsible AI Dashboard, which is a collection of tools that helps you understand things like error analysis. Where in my model am I having error? Being able to look at different cohorts, being able to look at the statistics against some of these different cohorts, being able to do, fairness assessments against the different, slices and things that you may want to look at, being able to do interpretability or counterfactuals, really understanding all the different things that can happen. It's a really powerful tool and really helps our internal developers as well as our third-party developers using Azure Machine Learning really make sure that they're building models in a responsible way across the full suite of applications that they manage. So those are the key things that I wanted to hit on. I know we're pretty late on time, so I don't know if we have too much time for questions, but really, thanks for the opportunity and excited about all the wonderful things that are happening in AI these days.
I think it was a really great session already, Eric. Microsoft is really doing a great job in adding so many extra services. I really love it how it's also get built into the end products of Microsoft, like we saw in Dynamics 365, in PowerPoint with the designer, or in Teams and all these things. And then bring it all the way to the software developers to bring in their own AI when you don't have any AI skills, and then all the way for the data scientists, which is really all the steps, which makes it really nice. So
people finally are going to use it.
Yeah.
Yeah.
Everyone can use it, and that's the great thing. It's democratizing AI, and I think that's what Microsoft is trying to do.
And that is a good thing.
Yeah, exactly. Eric and Beatrice, we're looking forward to having you also in the panel discussion in half an hour. So thanks already for joining us now, and we'll see you in a bit again.
Thank you so much.
Thank you.
All right.
Bye-bye.
We will be gone for a couple of seconds, and then we'll be back with our next keynote.
Hi, my name is Ruth and I'm from New York City.
Hallo, ik ben Danny de Klerk uit België.
Bonjour, je suis Jean-Philippe Encausse de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hey iedereen, ik ben Sammy uit België.
Cześć, tu Bartosz Mikulski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan， 来自台湾。
Ne ba he kelemu. Abum Pascal, jibezi alemezi.
And we're back with our next session. Hi, Manu Veer. Thank you so much for joining. Welcome to the show.
Hi, it's a pleasure to be on with you. Thanks for having me. I'm looking forward to the session. And do you want me to just share my presentation now?
Maybe you can first do a short introduction about yourself.
Yeah, my name is Manuvir Das. I work at NVIDIA. I'm responsible for enterprise computing at NVIDIA. As you know, we're huge believers in AI. We've done a lot of work in AI, and we now see this this phase of the journey where enterprise companies are really beginning to adopt AI quite heavily. And we need the developers in the community to really help enterprise companies make their companies better through the use of AI. So I think it's a fantastic moment to be having this conversation.
Yes, totally agree with that. So you're going to talk about the developer essentials for the new era of AI. Are you ready for it?
Yeah, I'm absolutely ready for it. So maybe I should share my presentation.
Yes, the floor is yours.
Let me take 1 second to get organized, and then.
Where are you located, Manovir?
I'm in Seattle, Washington.
Okay, right.
In fact, I worked at Microsoft for many years, for 15 years. And I was part of the developer team, working on Visual Studio and things like that. So I've been born and raised as a developer myself, and I love the what developers do every day. The creativity, because no one entity can have all the ideas. So you want to build a platform so that developers everywhere can just do great work with their ideas, but not have to repeat the same work that is common. So you build a platform with common tools, and then developers just build on top of that. I think that's a great philosophy.
Yeah.
So, okay, so I'm going to try to share this now. And do let me know if you're able to.
Yeah, it's going through.
Yes.
See that? And I'm just going to put it into slideshow mode. Show it. It's not happening. So,
when I see the NVIDIA logo, I always think about gaming.
That's right. That's right. So you can see my title slide now, right?
See it.
Are you able to see my title slide?
Yes, we can see it.
Great. Okay. Yeah. So as you said, the title of the presentation is Developer Essentials. And what I really want to convey to the audience today is what we have been doing at NVIDIA to really help developers quickly contribute to this amazing area of AI. Okay. So I want to start with just for the 1 or 2 people in the audience who might not believe it yet, this is a massive opportunity for all of us. Just one study by McKinsey, for example, talks about $1 trillion of incremental business opportunity through AI. I think if you just look at the statistics of late, there's 96% of enterprise companies have some AI project at some pilot stage. So I would say, on the one hand, we're in this journey where companies are really beginning to understand that they ought to embrace AI, but many of them are very, very early in their journey, and they don't yet have the right applications and the right tools to get benefit for their use cases. So it's a fantastic time really to be a developer. The way we describe it sometimes from NVIDIA is this is like the smartphone moment for AI, where there's so many different use cases, and creative people can think about the different use cases and build AI solutions for them. And our role at NVIDIA is really to try to provide that smartphone, that is a platform that people can use. And of course, you heard from Eric and the great work that's happening at Microsoft. There's a number of companies. So this is clearly something that we are part of, that we participate in from NVIDIA. But as well, so many others do as well. And we just try to make our own contributions. And so what I wanted to share a little bit today was the ways in which we at NVIDIA are trying to make our contribution in conjunction with Microsoft and Google and Amazon and just so many providers out there. Okay. So just a few facts just to get everybody caught up on who we are and what we do for AI, because it's easy to think of NVIDIA as the gaming company or the graphics company. I think a long time ago, a decade ago, at least, we realized that the same acceleration technology that we have in our graphics card turns out to be the perfect acceleration technology for deep learning, which of course is a fundamental part of AI. And so that's when we embarked on this journey of accelerating AI. And what we saw were dramatic accelerations, right? 10x, 20x, 100x, a few 100x times acceleration, which really made those algorithms tractable for the first time. And so since then, just some stats for you. We have more than 1 billion GPUs out in the field. We have our SDK called CUDA, which is our lower level interface for programming against a GPU. I'm sure many of you in the audience are familiar. We've had, a lot of downloads, as you can see, thousands of applications developed. The thing that we're most proud of is we have 3.5 million developers registered who work with our stack in various different ways. And that's really the main thing, because that's how everybody in the community can benefit from the work we do. So so I thought I'd put that slide up there just to give you an idea. I thought I would share 3 ways of thinking about our contribution. The first, of course, is that we accelerated the GPU. And as you know, we've taken the approach that we have an interface called CUDA. And as we move from one generation of GPU to the next, or from one kind of GPU to another one, even in the same generation, we have one API, which is called CUDA. And so what that does is it makes sure that as a developer, when you program against a part of our API for some functionality, then it's the same code that you can have regardless of which GPU you use. And then when we move from one generation of GPU to next, your code carries forward, right? So that's very important to NVIDIA's approach. And of course, I think it's very important for developers. So clearly we have accelerators that make AI go faster. And we, as you know, we participate in MLPerf and these things. And we are number 1 on that regard on all the benchmarks. We are a full stack company. I think there was a person who said a long time ago that people who really care about software do their own hardware. And at NVIDIA, we do the full stack. So we design the GPUs, we design the systems, how GPUs are connected together, how they're connected to the CPU, what the interconnects look like, how much memory you have on board with the GPU on the device. So we think about that whole architecture, and then we go up from there. So anytime we are working on a particular workload, for example, large language models, we do all the software algorithmics to do the training for large language models, but we're also very aware of what the bottlenecks in the hardware can be, and then we design the hardware accordingly. And as we evolve our GPUs, for example, we put in different kinds of operators into the GPU to enable more efficient processing of some of those algorithms. So we are very much a full stack company, and we do we optimize across the full stack. And then finally, we run a lot of software. NVIDIA today is much more a software company than a hardware company. We have thousands upon thousands of software engineers. We have more software engineers than hardware engineers by far. And we've developed a huge number of SDKs, and we make them all available. And many of them are, of course, available on GitHub. And so they're pretty easy to find over there. And we work with the community on these. I'll go through these SDKs a lot more. But so this is one slide to say, here's the 3 ways you can think of us and our contribution. At the base of it, we build these hardware accelerators that anybody can use to really dramatically speed up these workflows so that they become practical. The second part of this is we optimize across the full stack, and then we make all the software available to the community to use and to build upon. Okay. I think a good point to make here is that there's been an interesting inflection going on that many of us are aware of, which is that more and more of the workloads are in the public clouds now, and that movement is just going to continue, right? And as some of the companies that you're familiar with have done an amazing job building this cloud infrastructure, right? And so there's good reasons why the world is moving to the clouds. Now, the reason I bring this up is because NVIDIA is the accelerated computing company. That's what we do with our hardware and software. And there's 2 ways of thinking about why accelerated computing matters, and why, as a developer building an application or some kind of platform, why you should care about accelerated computing. The old reason was that When you accelerate your application, it runs faster, you get results faster, you can process a bigger workload and all of that, and that provides value to your ultimate user or customer, right? But now there's a second value of accelerated computing which becomes crucial, which is that it saves money. And the reason it saves money is if the same workload can be run on a fewer number of servers over a lesser period of time, then even if the cost per server is a little bit higher, the overall cost of running the workload is much, much lower. Now, when you're sitting there running your workload on premises or running your application on premises, you've already got the infrastructure, the non-accelerated infrastructure in your building. And so, yes, I can come to you and say, hey, here's this other infrastructure with acceleration in it. And if you run over there, you'll save money. But at the end of the day, you have to procure the new equipment. On the other hand, think about what happens in the cloud. When you run something in the cloud, you're renting instances. You're renting them by the hour, by the minute. So as a developer, if you have built an application or a workflow in the cloud and you choose to integrate with acceleration to make your workflow go faster, you're going to immediately save your customer money because they're going to have to rent fewer instances for less amount of time. And again, even if the rental cost per instance is higher, the overall cost is going to be much, much lower. So I think that's an important thing to keep in mind and consider. Okay, so this body of software that we've been working on for years now at NVIDIA, we think of it as two levels. Okay, one is we have a plethora of SDKs that are like building blocks and tools that a developer can use to do their own work. For example, we have GPU accelerated TensorFlow and PyTorch, and you can use that if you're doing some deep learning for part of your workflow. And I'll talk about more examples. And we've had that for a few years, and they've been quite widely used. But in the last couple of years, we've really put a focus on what we call workflows that are higher level pieces of software. As you all know, any AI use case involves multiple steps. It's not just one piece of code, right? You have to process the data, you have to do some training, then you do some tuning, you do inference. There's many steps involved. And so we've built a whole set of libraries, if you will, now that are for these end-to-end workflows. And I'll be sharing that list with you and talking about that a little bit more. So I think there's two ways to engage with the software of NVIDIA. One is at the level of picking up the lower level tools and doing your own end-to-end workflows on top of that. And then the other is just to adopt one of our workflows and build upon that. Use that as a starting point, reference design, if you will, and then either extend it or modify it or integrate it into what you've got. So two ways to develop. Okay. Again, we know that AI is essentially a four-step process where you find your data, you prepare your data. That can be quite a time-consuming process. And then you do your training, whether it's deep learning or simpler forms of machine learning. And then you do some level of tuning, optimization, and then finally you deploy for inference. So at that lower layer of tools, we've got a number of tools that make this feasible. We built something called NVIDIA Rapids. It's open source at rapids.io. And it's basically the data science constructs you're familiar with, like pandas, that we have built versions of these that are accelerated on GPUs, and they are dramatically faster. On benchmarks, you'll see 20 times the performance, 25 times the performance. If you target these, your data processing to GPUs, we're all developers here. It's not a free process. We match the APIs, but it's not a flip a switch and it just works. There's some amount of retargeting that one has to do. But if you do that retargeting, as I said, you get orders of magnitude benefit. The other approach we've taken along the way is we've also taken Spark, which is very commonly used for data processing, and we've used the same Rapids libraries to accelerate Spark. Now that one we've done completely transparently. You literally flip a switch, you don't change anything else, and some of your operators run on GPUs instead of CPUs. You get lesser performance benefit. Instead of order of magnitude performance benefit, you'll get several times performance benefit. And again, it just saves money because on a TCO level for the user, but it's completely transparent, right? So two ways to go to improve your data processing. Either you adopt Rapids and do the retargeting from Pandas, etc., to Rapids. There's a little bit of retargeting you have to do, and you can get dramatic acceleration. Or you just use your Spark pipeline and you just flip a switch, and and you get instant benefit with no code changes at all, right? So that's Rapids. And then for the training, we've got PyTorch and TensorFlow targeted to GPUs, and we constantly optimize that. We've got something called Tau. Tau is basically for your retraining loop. You've trained a model already. You've got a pre-trained model. Now you want to add some data that you have or a different context, and you want to retrain. So Tau is a toolkit that enables that loop, if you will. For a long time, there was a belief that you do your training on GPUs and you do your inference on CPUs. And what we realized a few years ago that actually the GPU accelerator is an awesome place to do inference. So we built a runtime called TensorRT. And then on top of that, we built a library called Triton, which is basically an inference server for model serving. And it's very, very performant relative to CPUs. There's a lot of advantage, both again in TCO in terms of how much hardware you need to use. And also, especially when you're in real-time use cases, then you get much faster result. So you can do interactive kind of things. So that's NVIDIA Triton. So that's a glimpse of what we have in the lower layer, if you will. And then the other way to go is at the upper level, as I said, where we have more complete sort of workloads for particular use cases. So I'm showing this to you here, and I've broken it down by areas. So the way to understand this is basically each of these frameworks that we built is for a particular domain that I've put in parentheses under the name of the framework. And then at the top of the slide, I've given examples of use cases that one can use. So for any of these frameworks in its domain, it enables a plethora of use cases. And then as a developer, what I can do is I can take one of these frameworks and I can add whatever else I need to add to complete the use case. So as you all know, a very, very common application of AI is video analytics, out on the edge, in factories, etc. We have a framework called Metropolis that provides all the common functionality for video analytics. And then you can use it for a variety of use cases, and I've given you one example there with traffic, right? We have a framework for conversational AI. It's called NeMo, and that's where we do a lot of work on large language models. And so you can imagine use cases like chatbots or for employees at a company accessing a knowledge base and such. We've got a very interesting framework called Morpheus for cybersecurity. Every company cares about cybersecurity now, and for developers, I would say, there are obviously large companies focused on cybersecurity that build big products that cover a range of things. But interestingly now, as a developer, you can quickly build particular solutions for particular aspects of cybersecurity that companies find valuable. And I'll give you one example from NVIDIA. NVIDIA's corporate network was actually compromised in February of this year. We were attacked. And what we realized was that we have so many employees logging in and using different systems, and one of our employees had been impersonated, and then that way they got access to our network and extracted some amount of information before we found that and we blocked that. So we built an AI framework called Morpheus, and we did this use case called digital fingerprinting, where basically we gather all the logs from Azure Active Directory, from Duo standard systems that we use in our company, and we feed this to our AI engine in Morpheus. And basically what it's doing is it's creating an individual model of every employee in the company in terms of what their regular pattern of behavior is. Do they go to the travel website? Do they go to the expense reporting website? What do they do in a normal day of their life? You build a sort of a model of each employee. And then against that model, the system observes the actual interactions of the employee. And so as you can imagine, it can flag when it sees abnormal behavior, right? It's like anomaly detection with AI. And we use this system every day at NVIDIA, right? And it's one of these point use cases. So any of you can pick up this framework we've built for cybersecurity called Morpheus and go develop use cases like that, whether it's digital fingerprinting or anything else you want to do. Riva is a framework for speech AI, for ASR, which is audio to text, for text to speech TTS, and it can be used in chatbots and lots of different contexts. Trading floor transcription, for example, for banks and financial companies that have saved all the audio recordings of the interactions, and then if you convert it to text, obviously that makes it easier to process. So that's called Riva for speech AI. Merlin is our recommender system framework. As you know, recommender systems are what drive the internet today. It's all about personalization and showing people what to watch next, what to read next. And so that's a framework for that. Modulus is we model actual physics and do very accurate simulation of physics. And then finally, co-opt is it's basically solving the traveling salesman problem, but on GPUs, so much more powerful with certain heuristics so that these problems become tractable. Okay, so this is a quick rundown of our workflows. So the final point I wanted to make was that we love the choice that customers and developers have in front of them today, which is there are public clouds. Obviously, we've got Azure as a good example. You just heard from Eric, but we've got all the public clouds, and then you've got other providers in different regions that also provide shared infrastructure. You've got people running on premises. You've got co-location areas like Equinix, etc. So customers can really vote with their feet as to where they want to run a particular workflow. And what we have chosen to do at NVIDIA is we're an open platform company. We're agnostic. We build everything so that it can run everywhere, right? We love containers. We put everything into containers so that you can do Helm charts and run things on Kubernetes. We avoid taking dependencies on particular things that are only found in one environment versus the other, and that allows us to be quite portable, right? So those frameworks and things I was showing you earlier, they run anywhere. So the easy way to interact with us is to join our developer program. It's developer@nvidia.com. As I said, our stuff is available everywhere. If you go to NGC, this is the repository where we make everything available. It's all free. It's all containerized. A lot of our code is also on GitHub. So you can either just go to GitHub and pick up our code and do the usual thing of playing with it, or you can go pick up the same stuff, but it's packaged into containers, so it's very easy to deploy. And then the thing that I'm really excited for all of you that we focused on a lot in the last year is we've built this experience called Launchpad that any of you can sign up for, where we've spun up infrastructure, a lot of infrastructure, and these workflows and things that I showed you, they're all available there. So if you sign up, you can try out these different workflows and you can do your own development and make very rapid progress. And the experts that we have at NVIDIA, the data scientists, the engineers who develop these workflows, etc., they can work with you very closely to help you as you develop your application. So I think that's a great starting place, which is just NVIDIA.com Launchpad. So 3 things to remember: developer.nvidia.com, which is the way to connect it with us and find everything we've got. NGC is our repository where you can easily pick up all these things in containers. And then Launchpad is this sort of free experience where you can try everything out. So really super excited to have been able to share this with you all. It's a very exciting time for AI, and looking forward to working with all of you going forward. So I guess I'll stop there.
Manuveer, thank you very much, and very good to see that NVIDIA is really putting a lot of effort in AI. I was a bit surprised to see that all those models are already pre-built by NVIDIA.
That's right. That's right. And I had this schematic I realized that talked about the SDKs and the frameworks, but in the process of building these frameworks, of course, we've done a lot of training ourselves on the infrastructure we have. So we have a lot of pre-trained models that are also available at NGC. So for a developer, you can pick up the code that we've built and build your own solutions on top of that, but you can also pick up the pre-trained models that we've created, and you can start from there. So you don't have to start all your training from the beginning.
Yeah, I'm definitely going to sign up for your developer program after this evening.
I think we need to advertise it a little bit more, because I also had never heard about it. So I think it's something that the community needs to more
That's
about.
Great feedback. So firstly, I really appreciate the opportunity then, because at least I was able to share that with your audience. But yeah, your point is well taken. We're really going to focus much more on sharing this with everyone. Yeah.
Because at the end it makes sense. You make the hardware, and to have the hardware, you also need to have something that's how do I need to say it? Who can interact with the hardware to try it out, and to build extra services as well for your own organization. And you build out some research.
Yeah.
And if you can share that research, that's awesome.
Yeah.
Yeah, because the experience we had was that as we got into AI, we got into all these new use cases that nobody had really done before, right? And as we worked with companies, we realized that somebody has to build that software for that use case. And we ended up being the people who built that software. And that's how our company really evolved and became a software company, So, yeah. And we're super excited to share all that body of software, with the community. Yeah.
Really great. Thank you so much.
It's my pleasure.
For joining us and for your session. And have a great day.
Well,
ahead.
We're still, if you can still stay in the call for a panel discussion, no?
No.
Actually, so we have Eric Pounds will be joining the panel discussion from NVIDIA. And
my mistake.
He's much smarter than I am. He's much smarter than I am, so I think you have a fantastic representative there. But it was very nice spending the time with you. Thank you.
All right.
Thank you so much for joining us.
Have a good day. Bye-bye.
Yeah, thank you. Bye-bye.
Hi, my name is Ruth and I'm from New York City.
Hallo, ik ben Danny de Klerk uit Italië.
Bonjour, je suis Jean-Philippe Pancos de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hey, ik ben Sammy uit België.
Cześć, tu Bartosz Polski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan， 来自台湾。
Hey everyone, and welcome again at the Global AI Developers Days. You are now watching the kickoff event that is all about the possibilities of AI. In the past 2 hours, we have seen the inspiring keynotes delivered by our panelists. Now, this is your chance to ask our amazing panelists the questions you've always wanted to get answered. Now, to do this, if you have a question, use the chat on your platform of choice, and our moderators will pick them up. Well, moderators, that's Shoka and me. So let's welcome our panelists and get to know them a bit better. So we'll start with Eric Boyd. We have 2 Erics on the call, but we'll start with Eric Boyd. So Eric, thanks again for your insights that you gave during your keynote about AI innovations at Microsoft. As I said before, I was really impressed how Microsoft really tries to democratize AI and all the work that your team is putting into that. Now, since the first Global AI Bootcamp in 2018, you have been part of all the events throughout the years. So I hope for many people you are a familiar face, but for the people joining and being part of the community for the first time, could you quickly introduce yourself again for the ones who are just joining this call?
Happy to. Yeah, I love the community and happy to be a part of it. So I'm Eric Boyd. I lead the AI platform team at Microsoft with fabulous tools like Azure Machine Learning and our suite of cognitive services.
Yeah, thank you very much. Just a random question to make people get to know you a little bit better. What was the first computer you touched?
First computer, I mean, my dad had the original IBM PC, but I didn't get to use that one too much. So my first computer really was the TRS-80, the Tandy color computer.
Okay, cool.
Nice. Our next panelist is Ekaterina Marinova. Welcome, Ekaterina. Thank you so much for your useful talk about all the skills you need when you are working in the field of AI. I really learned a lot, and I also noticed that I have lots of skills that I need to add as well. I want to ask you a short question to get to know you a bit better as well. What was the first AI project that you have been involved in?
So thank you very much, and thank you for having me in these great panels, these great discussions. My first project, so I was working in Microsoft back then, and my first project, and I got it afterwards, everybody was chasing me for that, was actually working on a chatbot, which I considered like a very, very deep AI project. Back then, this was like the first thing that I was working on, but it was a chatbot solution that further developed within the organization and within machine learning within the organization, and working with the employees and the organization back then, the company.
Nice, great project to work in, and also a background at Microsoft. Wow.
I started my career there. Yes.
Yeah. Okay.
Amazing place.
Great.
All right, and then we go to Francesca. I really liked in your talk how you brought all the items together and the machine learning operations, all the tasks that needs to be done. And you also show that MLOps is not just a tool; it's also a way of thinking how you start your projects. Also, a quick question to you. What's the first software that you touched?
So first of all, thank you so much for inviting me today. So the first software I touched was MATLAB, which was a software that as a scientist we were using at university to run a few data analyses. And that was the first software that I used. And I have to say was the first software that gave me the possibility also to start working with data and start building those preliminary machine learning models.
Yeah, interesting.
Yeah. And our last panelist, Eric Pounds. Welcome to the panel. Eric, you work at NVIDIA, and we heard some great insights from your colleague Manu Veer about the essential things you need to know as a developer in this new age of AI. Welcome to the show. And we have a question.
Thank you for having me.
Yes, great that you are here. And of course, we have a question for you as well.
Sure.
To know you a bit better. What was the first game you played?
Wow, a lot of things can be qualified as games, but I guess I can remember my first electronic game. It was a miniaturized arcade version of Q*bert. I guess I got it sometime in the early 80s, and I'd sit on the floor and play it for long periods of time. And actually, that reminds me, I need to go to my parents' house and find that game. I need to save it.
Okay, great. I don't know that game.
Me neither.
No, no.
No. Erics are laughing with us now.
So if you found it, please share something with us about it.
We'll do.
Yeah.
There's those specific streaming platforms where people are gaming on. Maybe you can start your own streaming channel. Okay, so we're here not to discuss these kinds of things, of course. We're here to talk about the future of AI. Well, there's no doubt that AI is getting more and more embedded in our daily lives, and we see it everywhere around us. Now, in solutions that help us do our work better, faster, and even more accurate, but also solutions where we put decisions about our lives in the hands of AI systems. I'm super excited to hear from you all what you think about the future impact on AI and the society. But before we dive into the future, maybe you'll need to have a good understanding of the state of AI right now. So maybe Francesca, I can start with you. Can you tell us the current state of AI, what is possible and what is not possible?
Excellent question. So I do think that the current state of AI is, first of all, very interesting from a professional point of view, in the sense that there are many different professions that have been created around this field. So when I started many years ago as a data scientist at Microsoft, I have to say that my profession was considered a little bit new. A lot of people didn't really understand at that time what I was doing. And then the more I have been working in this industry, the more I noticed that there are so many additional professionals that are working also with me. Like I work with now data scientists, machine learning engineers, data engineers, MLOps developers, also product managers that are the ones that develop the tools that are then used by all these professionals. So what I think that is currently possible with AI is the fact that we have this exposure of AI to many different people around the world. So you don't really need to be a data scientist, or you don't really need to have a PhD to work in machine learning and in AI to build those solutions that then are going to have an impact to other people. And so there is all that theme about democratizing AI and also the creation of machine learning solutions and AI application, which is great. During my talk, I also presented a few open source tools that have been like super well integrated also on the cloud. I myself and my teams, we work a lot with Azure Machine Learning, and some of those tools that I presented are PyTorch, TensorFlow, Ray, if you are in the reinforcement learning field. And so all of these is great. Like, I think that we all are in a moment of history where we know that that there is so much potential in AI, and a lot of big tech companies are working to creating those tools that are opening up the potential of AI to many different people, which is great. On the other side, what you also asked me, part of your question was like, what is not possible with AI? Well, there are a lot, of course, of risk with these potentials, because of course, when you start opening those tools, those open source frameworks, those AI application APIs that a lot of people can leverage in order to build those solutions, means that, of course, there are many different individuals that can start building their own application. There are many different data that can be used, and that, of course, create a risk also from an ethical point of view. So I do think that there are some tools that needs to be implemented as part of the current situation. I personally use a lot of also Python packages that can help with that, such as InterpretML. We have Fair AI, which are like great tools also to assess the level of fairness of your AI applications. However, there is still a lot that needs to be done everywhere in the industry in terms of privacy, data governance, and more of these things. So that is, in my opinion, an aspect of AI that we need to keep investing on.
Right. If you look at it, what is possible now, we see that more and more people who do not have AI skills can start building their own tools. But of course, they need to be careful what exactly they're building. And therefore, of course, we have the specific frameworks that are there that can help them to grow into building something responsible, for example. Now, if you would be allowed to pick one project that you say, like, this is really the best AI project that is being built at this moment, what project would come in mind?
Well, a project that I have been probably working a lot with a few students at university, actually. So it's a project that I have been working on actually during my weekends. It's about image recognition for drug discovery. And I don't want to mention the project as like the only example of the best AI project I have been working on, but I want more to talk about the field. I do think that right now AI and machine learning application have been used a lot in the field of drug discovery. And I'm based in Boston. So in Boston, we do have a lot of biotech companies and also pharmaceutical companies, and also a lot of startup researchers and students that are working in this field. So I'm not going to name one specific applications or one specific project, but I do believe that that is also a huge field for AIs to contribute to. And we saw, of course, some of the results also recently after the global pandemic that we all had to face, and some of the discoveries that help us also to overcome that very challenging moment, that pandemic. They had been actually discovered by some researchers in the Boston area using machine learning AI on, of course, drug discovery use cases. So I do think that it's probably one of the most inspiring cases where I see that AI is really helping our society to overcome a very challenging period of history.
I can imagine, especially in drug research, that a lot can be done and fast forwarded, and research that before took a lot of more time. Eric Boyd, do you have anything to add on to what Francesca already said? Oh, we cannot hear you.
Maybe
Just
you're
give
on
us a
mute.
second.
Yeah, sorry, my fault. So I think there's so many different and exciting fields that are moving so quickly that to say, like, what is the state of the art, like, and so Francesca talking about sort of vision and drug discovery and all of those. I think there are a lot of interesting applications there. The place I'm most excited these days is in the large language models. We've just seen, they've just exploded over the last 3 to 5 years, and they continue to get more and more powerful. And the types of things that you can do, I think, are really going to be, pretty amazing. And you combine sort of those language models now with sort of generative vision models and some of these diffusion models and things like DALL-E. And so now you've got tools where someone who's not particularly creative, who's not particularly talented artistically, or, maybe is struggling to sort of come up with something to write, now has these tools that can really unlock a lot of potential for them. And so I think a lot of that's really pretty exciting.
Yeah, those are very pretty exciting. I've seen some examples of DALL-E, and that's a really promising model. Yeah, totally agree with that. I'm very impressed what AI can all do and how fast things have evolved in the last 10 years. Now let's move 10 years into the future. Eric Boyd, what do you think about the future of AI? Is it going to change the world as we know it in 10 years?
I think someone once said that we overestimate how far things will go in 1 year and underestimate how far they will go in 10 years. And I think that's probably the case. The types of things that we're seeing that AI is capable of doing can completely change the way that we interact with computers, what we expect for them to do. The kinds of things that we've been sort of dreaming of, oh, I'll just talk to my computer and it'll just have this assistant, the Star Trek, assistant. Those things are all going to become real. And so it's a matter of when exactly, but the potential for it is really sort of seems like it's coming quite quickly. And so I think it's going to really force us to rethink the interaction patterns that we have. How do we, the machine human interface right now is mostly typing. It has switched to swiping on phones. I think a lot of it, more of it's going to be vocal, and it's just going to be much more ambient. We'll see a lot of it more around us because we'll have the power of computing, plus we'll have the power of the AI technology to really enable those types of things. So I think it's going to be pretty profound. And I really feel like, we keep seeing sort of the knee and the exponential curve. The AI power in some of these models is really just starting to race up that knee. And so I think we're going to be pretty amazed at the types of things we're able to do in the next 10 years.
Yeah.
Well, I think exactly, Eric, as you said, we have the DALL-E and the GPT models and so on. They're really going to change the way we are looking at certain things, or having specific business processes that might be automated in ways that we've never thought about. But that, of course, brings us to other items. It's all of those items need serious compute capabilities. And then, Eric Pound, I start looking at you also. Where do you think all that, will we get there? That's, well, we have very powerful GPUs now. Are we still in a growing curve, exponential, or how are you looking at that for the next coming years? Will we be able to get enough compute power?
Yeah, Eric, Boyd, you mentioned LLMs, large language models. I think first off, what's available today is extremely exciting. Like in large language models, for example, a year ago, in some of the folks on our team working with the Microsoft team, we trained a 530 billion parameter model, the Megatron Turing NLG model. And we, at NVIDIA, we recently demonstrated our AI framework for large language models, NeMo Megatron, on Microsoft Azure, powered by NVIDIA A100 Tensor Core GPUs and InfiniBand networking to tie all that together. And that framework is today designed for billions and trillion parameter models. So it's possible today. I'd say the future capabilities available to us are very promising and exciting. I think one thing everyone needs to think about, and Manuvir touched on this in his session, is one, it's a full stack challenge. So as the hardware capabilities evolve, they can only reach their full potential with the software evolving in lockstep. So for example, like at the hardware layer, there's a lot of things that can be done, but we need to think much bigger than just the instance, the system, or the cluster. We need to think data center scale, cloud scale. These models are very, very large, and they need to span many, many, many instances and nodes, and they need to all work together. But within the system, there are advances coming. Like in NVIDIA, we just recently announced and launched our H100 Tensor Core GPU, which will deliver significant faster processing on these larger models as a new transformer engine built into it. And we also take these and then assemble all these capabilities into SuperPod-like architectures to find optimal ways to scale. So there's promising things moving forward. But training, customizing, and leveraging these large models wouldn't be possible without these software innovations. These frameworks to substantially reduce the time and cost to fine-tune these models for specific tasks. And also then throughout the life of these hardware generations, the software will keep evolving to make these systems even more capable. Like, I mentioned how, what we were able to do on the A100 GPU and a large cluster of those just last year, that may not have been possible when we announced and launched the A100 initially. A lot of the software evolved to take advantage of a lot of these capabilities. So anyway, a good way to be thinking about the future of computing and how it can be leveraged.
It really goes hand in hand, software and hardware, and then yeah,
exactly.
Eric, Boyd, do you have anything to add to this?
I mean, I think I agree with a lot with what Eric Pound said of there has been just phenomenal hardware, performance improvements, and we certainly are looking forward to doing a lot more with the H100 series of chips, and very excited about the potential that'll come. So I think we do see that the hardware is growing. Moore's law is definitely suffering, but we're still seeing tremendous power growth, and so I think that's something that we can continue to look forward to.
Endless possibilities. Yeah,
Exactly.
and don't think we have to wait 10 years for that. No. Okay, next question is for Ekaterina. You have seen many projects over the past years, and also from different perspectives, from different companies, technical angles, and business overviews. Can you share your thought on how the future of AI will look in 2032?
Yes, thank you very much for this question. I agree with a lot of what the others have already said. My perspective, also based on my experience, is that in the beginning we were talking about research. Then we started talking about products, right? We were focusing on the technology, we were focusing on the products. Then we switched to solutions. So we started incorporating these products into different solutions and started moving towards selling and positioning those solutions. Now we are moving to redesigning industries. Now we're moving to redesigning industries through those solutions, through those technologies. And I'm absolutely sure that all of these will keep evolving, and we'll be talking about amazing technologies. We'll be talking about holistic solutions and full redesign of the industry, like new approach to the industry. And for sure, this will happen in the following years. I cannot say exactly how many years, because even before we were predicting that AI will be there sooner or data science will be big in certain time, and everything happens. With this technology growth, with this, like companies are adapting, technology is moving forward. But then on the other side, we have people, we have academia, we have the community, we have the recipients of this technology, the recipients of these solutions, and the way they accept it, the way they think about it, the way they think about this technology advancement, about this industry redesign, about these solutions. And I believe that the true growth of AI will come when it's incorporated in education, when it's incorporated in the communities, when we're talking about AI open data, when we're talking about this data philanthropy that I was talking previously, about AI being shared across organizations, across academia, across all those hackathons that have been organized. So talking about another approach, talking about another way of thinking of AI, not as something new, but something that's there, something that will be there, and something that will keep evolving.
Yeah, totally true. It's the people in the end that need to that are going to use it, and they need to adapt it before it can fully evolve. Yeah, thank you so much.
Well, I think without a doubt, AI is going to have a big impact on the future. But we also know, as Uncle Ben of Spider-Man says, with great power comes great responsibility. How do we keep our future selves safe from AI, making mistakes and doing the opposite of what we intend to do? Francesca, as a data scientist, this is kind of also in your hands. What are your thoughts of how do you make sure your models are fair and transparent?
That is an excellent question, and I try to cover part of the answer to this very important question also in my keynote today. Generally speaking, I try as a data scientist, and together also with my organization of data scientists, we try, of course, to follow some principles that Microsoft created. However, I do not think that these are Microsoft principles. I do think that those should be industry principles. And of course, if I can mention them, there are accountability, inclusiveness, reliability, safety, fairness, transparency, privacy, and security. So those are somehow the principles that as a data scientist, as a machine learning scientist, data engineers, of course, you always have to look at them and try to cover each of them, but most importantly, there should be like tools that allows you and your team to include them as a part of your data science machine learning lifecycle. I also think that it's important to make sure that there are open source tools available to cover some of these principles, if not all of these principles. So just to give you some more like applicable example for explainability, some of the open source tools that I use all the times are like for example the open source framework called InterpretML. So it stands for Interpretable Machine Learning. That is this open source toolkit that helps to achieve a model explainability. And what is very nice is that it produces for you in your notebook, or also if you're using another tool, like for example in my case I'm using Azure Machine Learning all the time, it allows you to look at those visualizations that really gives you a very nice overview of why your model is producing specific results. We call it at the global level and at the local level, meaning that you can get this overview, a very clear understanding of why your model is producing specific results, both at the model level, meaning at the different features and variables level, but also at the specific data point level, which is extremely important, especially when you are looking at the impact of your model to a specific, for example, user ID or to a specific customer ID. So the individual level, it's or local level, it's very important. So this is just one example. Another open source toolkit that I have been using very often is Fairlearn. It's integrated in Azure Machine Learning and is another Python-based open source tool that allows you to assess the fairness or the fairness level of your machine learning model. And that it's great, especially when you are using a specific data set that you think is representative enough of the population that you are targeting with your AI solution. So these are just a couple of examples, but what I'm trying to say here is that always try to integrate those tools and those open source toolkits in your solutions, and really they need to be part of your development cycle when you are building as a data scientist machine learning solutions and AI applications.
Okay, thank you very much. I think especially the frameworks that you mentioned already, they're very useful. Now, Eric Boyd, you are responsible for the AI department within all of Microsoft. How do you make sure that everything that is released is also responsible?
Yeah, I mean, we follow the, Francesca's touched on it, right? The AI principles, responsible AI principles. They're super important to us. And so we think a lot about how to develop models responsibly, so much so that we've also released the Responsible AI Standard, which is a set of practices that we follow. When developing a new model, we do impact assessment. So let's think through all the different ways that this model might impact people, and particularly the ways that we, might not think of, up front. And then we come up with what are the set of mitigations that we can come up to minimize those. And so really make sure that we're thinking through them responsible. What are the sets of tests we need to run? What are the tools that we need? How do we use tools like, Fairlearn, error analysis, and all these tools to help us understand, what's happening with the models? And so, having these practices and then really disseminating them throughout the organization is absolutely key to make sure that we're doing this in the right way. And, sometimes it leads to us making choices about we'll gate or restrict certain products. If you want to use custom neural voice, you have to have sign off from the voice actors. And so there are a number of things that we want to do along the way to really make sure that the products that we have are being used in the way that they're intended. Really, we just feel a deep responsibility as creators of this technology. We have to make sure that the benefits of it really accrue to everyone and not just to specific groups. And so keeping focused on that and thinking through the ways that we can do that better, that's the thing that really drives us.
Yeah, thanks very much. I would like to ask the question also to you, Eric Pound, because as hardware manufacturing, you guys also make a lot of frameworks available for the public. How do you handle that within how it's used, the services?
Well, I'll echo what Eric Boyd said as well. Also, I think that, so definitely the way that you not just the way that you develop your software, but the way that you test your software, really understanding your audience. A lot of these audiences are global, so keeping that in mind as you're testing and tuning these softwares and these models. I think the only other thing I'll add is just also deciding the domains that you decide to invest in, right? There's a lot of solutions for AI, and what you choose to invest in, what you choose not to invest in, I think is another big part of this decision process.
Okay. Ekaterina, anything to add up on everything that has been said already?
Well, everything that's being said is, I totally agree with. I'll go back to a point that I've mentioned. For me, when we're talking about responsible AI, when we're talking about ethics, when we're talking about thinking while creating this, thinking while we're working in this area, we should be talking about a holistic process. So having this in mind from the beginning until the end.
Oh, thank you so much. Thank you so much. We need to wrap up, but thank you all for your opinions, your visions, and that the willingness to share that with us. And we are really looking forward to the next 10 years in AI. Thank you so much, and also thank you for your sessions. And I hope you have a very good rest of the day.
All right. Take care all.
Thank you.
Bye-bye.
Bye-bye.
And that will bring us to our last session. We'll be gone for a couple of seconds, and then you will come back.
With our last session of this evening.
Hi, my name is Ruth, and I'm from New York City.
Bonjour, je suis Jean-Philippe Ancos de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hej, ik ben Sammy uit België.
Cześć, tu Bartosz Mikulski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan， 来自台湾。
Levar aquele album Pascal, tu peux dire à la musique.
Hey everyone, welcome
Hi
back.
guys.
Hi Ruth, how are you doing?
Hi.
Doing great. How are you?
I'm good. We're glad to have you today. Last but not least, of course, Ruth, can you please introduce yourself to the public? Who are you? What do you do? And yeah, what do you do at Microsoft?
That's a good question. Hi, everyone. My name is Ruth Yakubu, and I'm a cloud advocate at Microsoft. And I am on the AI and machine learning group.
Okay, cool. You're going to talk about improving the fairness and reliability of AI solutions. We've already had in our panel discussion quite some discussions about responsible AI, but I'm sure you will go more in depth with your session. So if you're ready for it, we give the platform
I've been listening
to you.
to the panel discussion, so I'm like, yay, they're setting the precedence.
So I hope it was a good introduction to your session.
What's that?
I hope it was a good intro to your keynote now.
They did a superb job.
Well, then the platform is yours, Ruth, and we are a listening ear.
Okay, so let me share my desktop. Give me a few minutes. And let me know when you guys can see my screen. Can you guys see my screen?
Yes.
Yes, we can see it.
Oh, it was delayed. You guys could see it before I could.
Oh.
So
it's the magic of AI, I guess.
Okay. Actually, that's a good way to start a session, but let me navigate to the very top. So give me a few minutes. While I'm doing that, do you have any questions for me?
Not yet.
Not yet.
Okay, give me a few minutes.
Okay.
Get to the beginning of my slide, then we can rock and roll. Okay. So almost there, almost there.
No worries, no worries.
It seemed like you guys see the slide up, refresh before I do.
Yeah, we can see.
We can see it.
Okay, so let me get started. So in this session, I'm going to talk about how we developers can improve the fairness and reliability of AI, the AI solutions that we um, train and develop. So, okay. So one of the things that is very exciting about AI is everywhere. It's part of our lives and it's at the cutting edge of everything that we do. Most applications, almost every application is infused with AI. But on top of that, almost on a weekly basis, we constantly hear these news headlines highlighting concerns of AI, areas where it is used or misused. So with this comes with a lot of societal expectation. The expectations that the society has is constantly increasing. And one of the questions is the trustworthiness of AI solutions. The next thing is, okay, if their AI solutions, they have their functionality overall, are they trustworthy? But also companies that are developing AI solutions, do they have our best interests at heart? So those are some of the things that we constantly hear in the news chatter when it comes to AI. So one of the things that Microsoft is doing is helping enable practitioners like data scientists, AI developers, and organizations on how they can develop their AI systems or solutions more responsibly, to make them more responsible. So some of the areas that are critical is risk. So like addressing all the areas or assessing the areas where there are negative impacts that may be coming from an AI model, or having the ability to really understand a AI model. So similar to how Francesca was mentioning, this comes into areas where we have to explain why a model is having a certain outcome, or um, being able to interpret the behavior of a model. And lastly is trust. A lot of people may think, okay, I create a model, people are using it, but over time, we have to think about the human aspect of it. Is it harmful to people? Is it reliable? Is it safe? That sort of thing. So making sure those are met. And also, when it comes to trust, it's also the way people perceive maybe an organization's AI solution. So you may be doing well, but have like a AI solution that had a negative effect on society, and that can totally ruin business or organization's reputation. So that's where Microsoft is keeping those in mind to help developers and companies be able to take those into the forefront of everything that we're doing. So the different ways Microsoft is making a lot of investment and commitment is coming up with these responsible AI principles as we embark on this new evolution of AI. How can we make it efficient and productive? But how can we make sure in the end-to-end processes that when we're training and developing these AI solutions, how do we make sure they're being fair, they're reliable, and safe? About privacy, how are they um, handling privacy and security? Then, when you have a model out there, how inclusive is it to different groups or different demographics? Then transparency, we can get into details on transparency, then accountability. So these are the key areas that Microsoft is really focused and committed into helping developers and organizations be able to produce AI systems that are more responsible. So I know a lot of you guys maybe wonder, okay, why responsible AI? We get the principles, but if a model is accurate, why should we really care? We've been doing business for a while. So one of the investment and commitment is around ethics and building solutions responsibly. So ethics and responsible AI. And when you think of fairness, reliability and safety, privacy and inclusion, some of the effects use case that come in this area are things like sensitive areas, like the consequences of the impact of providing opportunity. So you need to ask yourself a question. The AI solution that I have, is it limiting or denying access or service, or is it excluding a certain group? That's one area. Then what is the risk of the AI solution imposing physical or psychological harm to people out there? Then also constantly, when we think of society where AI is going to be used, is okay, what are the threats to human rights that potentially an AI system or solution can impose? Then the other area is accountability and transparency. So as most of you guys know, AI, when you have an AI model, it's a black box. So it's very hard to decipher from these outputs that the AI solution is given, how were the outputs derived based upon the input that it was given. So one of the areas is transparency. Being able to explain, not just explain why a model behaved the way they did, but now we have a lot of industries out there that have regulations where you have to be able to provide some kind of what's it called? Proof, explanation, auditing, and be compliant into explaining reasons why an AI solution predicted an outcome the way it predicted, or recommended something the way it recommended. So let's take the financial services industry, for instance. When practitioners or businesses or banks are issuing loans, they have to be able to explain why a loan was given to X person versus one person versus another. So being able to provide this transparency is important. Then communication. So communication is not just being able to explain how your model behaved, but you should be able to explain or disclose when, why, and how you went about building and deploying a model. And another way is also to be forthright into disclosing areas where the model does not perform optimally to the end user or the public. Then the last area is the ability for developers or data scientists to be able to evaluate and debug models and monitor models over time, but work very closely with stakeholders in terms of making decisions, empowered decisions based upon what the model is doing. Then lastly, at Microsoft, we constantly look at ways to make artificial intelligence real to businesses or developers out there by expanding on the AI technology and also with the open AI platform. So as you're wondering, what does this mean to you? With all the different commitments that Microsoft has made around responsible AI, what does it mean to you? So the good thing is Microsoft has developed a lot of tools and also infused it in our Azure and machine learning tools and our AI services to enable developers when they're building or training machine learning solutions to be able to build them and also debug them quicker. There are tools out there to debug, but how can they do it quicker and in a more efficient way, but also be able to deploy a responsible AI? Then also enabling decision makers. So providing that transparency for them to understand the model, but also to make decisions based upon the predictions faster and with more confidence based upon the holistic information that the AI solution is able to produce. Then lastly, improve people's perception and trust for the AI systems that we're building out there. So as an AI developer or data scientist, we're the traditional way of going about and debugging AI solutions is, hey, you go through and build, whether it's a classification model or a regression type of use case, you build the model, then how do I debug to figure out how effective it is? So let's say, for instance, I say, hey, this model is 93% accurate. Then we say, yay. But the question is, does that mean that it's 90 out of the 93% accuracy? Is it fair? Is it inclusive? How do we go about measuring that? Because a lot of the way we go about measuring our AI solutions are based upon calculations, but some of the human aspects are harder to decipher and to be able to really debug and see the accuracy of it. So an example is, let's say, a speech to text model, evaluating the accuracy rate and the tolerance of the transcription may be different for, let's say, a doctor's office versus making transcriptions for, let's say, a book. So how do you measure how accurate something is? So those are different areas that we need to take into consideration. Then the question is, what is in the black box? Because our models are black box. We have input, output. But how do we go about explaining how the AI solution is going about and making its prediction? So that's always a challenge. So as we think of all those challenges, to make it more real, let's think of some of the gaps that we tend to have after we create our model, the limited calculations in terms of measuring the performance metrics of a model, how would you be able to look at feature error distribution? So this basically means that in the areas that your model is failing, what features are contributing to that? In most cases, we don't know. Then how can we compare one cohort versus another? Because the model may be performing perfectly in one group of people, but when you expose it to a certain group of people, that's when the performance really is poor. So how do we go about exposing that? Then sensitivity, what features, sensitive features can we assess to evaluate the fairness? So I use example of a loan approval. So if a loan is being approved mostly for males than females, then okay, how do we go in and figure out, okay, where's the gap? Then explainability, interpretability, that as well. So if you're a doctor, you use AI system to help you make a diagnosis. The question, let's say you're audited, what were the key features that led you to diagnose a patient that they had this maybe ailment versus another? Then decision making. One of the things about AI is not just about data scientists or AI developers. We have to also bring in the business analysts and the stakeholders in the picture. So when a model makes a prediction, we have to think of what are the counterfactuals. So back to this case of, let's say, a loan approval. If you deny a loan to somebody, you should, and they ask you, okay, why was the loan declined? You can't say, well, the AI solution told me to decline it. No. The good thing, one of the things that we need to take into consideration is counterfactuals are, okay, what are the features that we can alter in order to change the outcome? So with that, you can tell the end user that, hey, if you increase your salary by X, or if you increase your credit rating by X points, you should be able to, the model will approve your loan. So there shouldn't be any ambiguity on the user side. Then also making recommendations. So decision makers being able to take a step back and ask hypothetical questions like, okay, what will happen if we introduce this new drug? What would be the effects of it? So those are different areas of when we're building AI solutions, how can we build them responsibly? So one of the things that Microsoft has really invested a lot of time is open source tools. I know Francesca mentions some of these: FairLearn, Interpret ML, Error Analysis, Econ ML, Hacks Tool, Counterfeit Dice. There's so many tools out there that the Microsoft research team has been working closely with organizations to be able to bring this holistic, what's it called, way of empowering developers to be able to debug and gain insights to help them be able to mitigate areas that they could be gaps into their AI solution and models. So let's take a look at what Microsoft has done. So In Build, back in May at Microsoft Build, we announced the Azure Machine Learning Responsible AI Dashboard. And this is a very useful tool because in the real world, if you have your model, instead of having multiple Python scripts to debug or use some of these open source tool, Microsoft has built a dashboard with all of these technologies in the back end for a one-stop shop place for developers. And knowing that Azure Machine Learning is the end-to-end solution for the whole machine learning life cycles, it provides you opportunity to be able to identify errors. So doing error analysis, figure out where in your model there could be errors. Also, fairness assessment. How do we figure out where whether your model is fair or not? Then once you have identified that, how do we start, while we're exploring, how do we start diagnosing? So doing model interpretation, doing counterfactual analysis, and also data exploration. Are they imbalances or disparities in the data? Then the next thing is, how do we go about mitigating it? So if there are unfairness, how do we go about fixing the fairness? If there are data disparities, how do we go about doing that? So to give you an idea, I want to go through each section of the dashboard. So the very first thing is error analysis. And basically, I just chopped up the key areas that are important. But when you launch it in Azure Machine Learning, it looks a little more pretty and intuitive, and each section is more easy to understand. So let's say you have a model, it's able to show you based upon a decision tree where your errors are most concentrated on. So the very first tree, like the dark red areas, it's like, okay, these are areas where most of your errors are coming from. It's able to show you a heat map, so you can dive deeper into certain features and to be able to see, okay, which subgroups of your data is the error coming from. Then similar to how we have feature importance, a good thing that error analysis also does is it gives you a whole distribution of, okay, these are the key areas that are causing features that are causing errors in your model. So that's the very end image. Then the next thing is having a model overview. So the normal traditional way that we have in terms of measuring AI performance metrics, let's say confusion metrics, or looking at the mean root square or R square metrics. The good thing is we still have those, but the good, I keep saying the good thing, we can see how excited I am. But one of the benefit and advantages of that, it goes a step deeper. You can create different cohorts and subgroups and be able to do comparison analysis of where your model is performing well and areas where it's having challenges. So those are the types of information that it gives. And all these heat maps will also show you areas that your model is struggling. Another thing is data exploration. So with data exploration, show you the disparities in your data. You can also compare X and Y axis and see, debug how certain features are impacting other features. And you can see areas where maybe your data set is overrepresented in a certain feature or underrepresented in another feature. So to go ahead and go back to the drawing board and change your data set. Feature importance is very important. So on a holistic level, so on a global level, as you're trying to figure out, okay, what are the important features that are leading to my model prediction, you can totally use the dashboard, and it shows you all the areas that important features that are driving your model's prediction. And you can toggle on the individual level and look at this specific individual for the use case that your model is trying to predict. These were the key factors that led to the prediction for this individual for their unique setting. Then lastly, we have counterfactual. So it'll show you how your data is dispersed based upon the prediction. But the good thing is in those dotted areas, you can click on one of the dots, like look at the certain individual data set. Let's say you're measuring, okay, how likely is the employee to leave a company? The prediction will show that yes, this individual is more, there's a prediction that this individual will leave the company. So what additional feature and capability this will give you is that decision making, like what features do we need to alter to make the employee stay? So with this one, it will give you, in my example, I selected, okay, give me 10 different alternative alterations I can potentially make for this individual to stay. So those are the powers of unlocking your AI model to be able to make decisions and to totally understand how well your model is performing. And another thing is also a good way to also catch errors, because let's say for a loan prediction type of scenario, I ask give me all the different counterfactuals that if a loan is disapproved for this individual, what can they do to change, get approved? And one of the suggestion is if they're male, the suggestion is like, okay, become a female, then your loan will be approved. Those are the areas that you can identify that, okay, there's your model may not be behaving correctly. So to end, what Microsoft has basically done in the Azure Machine Learning is incorporate everything that you're used to doing, building your models in the whole machine learning life cycle, from bringing the data, training the data, deploying the data. It incorporates all these tools for you to be able to debug your model, ship it out, and also with security, have also open source tools like Smart Noise or Counterfeit to help you for the security part, because you are dealing with data back and forth. So how do you mask the data for people prying eyes and whatnot, and also controlling like your inventory. So lastly, to end, I'd like to end by this quote by Brad Smith, the President and Chief Legal Officer at Microsoft. And basically, in the quote I like is, when your technology changes the world, you bear the responsibility to help address the world that you have helped create it. So if you help create a model that's harmful to society, you are also going to live with the consequences of that technology that you've built. So to end with, these are very useful resources if you want to learn about what Microsoft is doing in the area of responsible AI. You can visit AKAMS/RAI. And if you want to get a tutorial, hands-on tutorial, I know you guys can't wait to get the hands-on tutorial on how to build and deploy a model and also use responsible AI dashboard. With all the cool features that I mentioned, you can visit the second link for an end-to-end tutorial. Thank you.
Thank you very much for the insightful presentation, how we need to, all the things we need to think about when we want to build a responsible AI model. I think there's a lot of lessons that many of us can use in our next project. Thanks very much.
Absolutely. Thanks a lot.
Yeah.
Yeah, thank you, guys.
All right. Have a
great day.
Have a good
Yeah,
great
you
day.
too. Thank you.
Bye-bye.
Bye-bye.
Bye.
So that brings us to the end of day 1. We had a great number of keynote speakers. We had an awesome panel discussion. And now we're looking forward to tomorrow, a day full with community speakers from all over the world who are going to share their technical expertise, their ideas about projects they've done. So yeah, many nice things to look forward to tomorrow. We are starting our next day 2, let's say, in I think approximately 8-9 hours. So it's going to be at 6 a.m. Central European time. So if you go on the website, you will also see your timing and your time zone.
One thing to mention for tomorrow, we are going to do a quiz.
Oh, a quiz.
Where you can win awesome prizes. So you should definitely join us tomorrow.
Ooh, I want to win something, or I can't compete.
No?
I don't know.
Let's see tomorrow.
Well, I hope you will compete, and we will see you back tomorrow, even if it's just for 1 or 2 or 3 sessions. Have a look on the website, check what is really interesting for you, and then we want to see you back there then, and with a lot of questions that we can ask also the speakers. Thanks already for all the questions that you've sent into the chat, and we're looking forward to see you tomorrow again.
Thank you for watching.
Bye-bye.
See you tomorrow. Bye-bye.
Hi, my name is Ruth and I'm from New York City.
Hallo, ik ben Danny de Knecht uit Italië.
Bonjour, je suis Jean-Philippe Encausse de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hey iedereen, ik ben Sammy uit België.
Cześć, tu Bartosz Mikulski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan，来自台湾。
Ne ba yake lemu. Abum Pascal, tu peux dire allez, merci.